Hi, listeners. This is the 80,000 Hours podcast, where each week we have an unusually in-depth conversation about one of the world's most pressing problems and how you can use your career to solve it. I'm Rob Whitland, Director of Research at 80,000 Hours. It's taken us too long to do an episode focused exclusively on climate change, but I'm delighted to say that this first one is with Mark Lynas, one of the most independent-minded and forthright environmental activists that I'm aware of. Relative to many folks out there, we at 80,000 Hours are much more concerned about climate change because we see it as having tail risks that could ruin the future of humanity. And its negative impacts could be really very long-lasting. And of course, we're concerned about how things go not just this century, but for the entire future. But in other ways, we can sound less concerned, partly because climate change is already among many people's top concerns, and we want to draw attention to the most neglected problems out there that haven't really broken through to the mainstream yet. In preparing for this interview, Arden and I wanted to learn more about the impacts that climate change should be expected to have, the likelihood of it actually posing an existential risk to humanity, and also gather some ideas for which careers would do the most to actually limit climate change to tolerable levels. Both in his book and this interview, Mark was able to deliver on all three of those points. For the first 35 minutes of the episode, we largely just let Mark lay out his views. And after that, we debate some apparent disagreements, starting with the chapter titled Where 80,000 Hours is at on Climate Change. Regular listeners will know that we usually give guests a chance to just say their thing for a while at the beginning of episodes. Personally, I don't like immediately jumping in with objections before people have had a chance to explain where they're coming from. But in this interview, as every interview, that doesn't mean that we agree with everything that's being said. And more generally, these interviews are unusually long, but they're still only long enough to meaningfully object to a handful of things that guests say. So unfortunately, I can never follow up on everything that I'm not convinced by. The rest of the team here, after listening to a preview of this episode, thought that the second half, dealing mostly with the prospects of nuclear energy, was especially interesting. So if that topic excites you the most, you might want to skip ahead to 1 hour and 27 minutes in, or select the chapter called Nuclear 2.0, so you can listen to that section first. As part of our efforts to improve our climate change content, earlier this year, Arden Kayla, who joins me for this interview, made a medium-sized update to our problem profile on climate change on the website, which added more discussion of long-range climate forecasts and the most extreme risks that we might face from climate change. If you're interested to read that, you can find it at 80,000hours.org/problem-profiles/climate-change. Or you can just click the link in the show notes. Just one final thing. Unfortunately, Mark's sound for this episode isn't up to our usual level. Like so many people these days, all three of us in this episode were recording from home, which meant we didn't have our usual professional setup. In fact, Mark had to take the call from his car so that he wouldn't be bothering his entire family. It's not too bad, but if you prefer, you can read the interview on our website, where we have transcripts of every episode. We produce those transcripts because we know there's some people out there who just prefer reading things to listening, and also because people tell us it's useful to be able to go back and refer to sections of episodes and copy and paste sections that they want to share with others, and find claims that they remember people making and see exactly what they said. So you can find the link to the transcript for this episode in the show notes, and all of the others at 80,000hours.org/podcast. All right, without any further ado, here's Arden and me interviewing Mark Lynas. Today, I'm speaking with Mark Lynas. Mark is a journalist and author of several books on the environment, including 6 Degrees, Our Future on a Warming Planet, The God Species, Saving the Planet in the Age of Humans, Nuclear 2.0, Why a Green Future Needs Nuclear Power, and Seeds of Science, How We Got It Wrong on GMOs. As a green activist, he evolved from a more traditional desire to minimize humanity's influence on the planet to believing that humanity's enlightened stewardship of Earth's environment is the only way to avoid disaster. He's also gone from being an active campaigner against nuclear energy and genetically modified food crops to a vocal advocate in favor of both, as technologies that are good for the environment, at least if used sensibly. This year, he published a fully updated version of 6 Degrees, which aims to outline in detail the effects that different levels of climate change would have on nature and humanity. When he wrote the original in 2007, it won the prestigious Royal Society Prize for Science Books, was translated into 22 languages, and adapted into a National Geographic documentary. Mark is also certainly a man of the world, because he was born in Fiji, grew up in Peru, got a degree in history and politics from the University of Edinburgh, and is now a visiting fellow with a pro-science advocacy group at Cornell University. Thanks so much for coming on the podcast, Mark.
Thank you, Robert. Nice to be here.
And I'm joined again today by my colleague Arden Kayla, who spent some time updating our article on climate change earlier this year. Welcome, Arden.
Hey, great to be here.
All right. So, Mark, I hope to get to talk about your views on nuclear power and how likely climate change is to pose an existential threat to humanity. But first off, what are you doing at the moment and why do you think it's really important work?
Right now, I'm actually involved in two different areas of advocacy, if you like. Well, three, if you count the kind of broader pro-science work I'm doing with Cornell. One of those is in trying to build a pro-nuclear grassroots movement, which seems like a strange idea, right? People mostly think of nuclear as this sort of big military-industrial complex thing that governments do. But actually, for nuclear to be part of addressing climate change, which I'm sure we can talk about later, you've got to have sustained grassroots political support. So getting people who've been involved in Extinction Rebellion and direct action for climate activism, and to put all that energy and sort of exciting enthusiasm into something which is actually a solution is really key. I'm also involved in doing work with Rewilding Britain, so actually to get more of our land areas devoted to a wilder landscape with better biodiversity and climate results. And as I was saying earlier, broader pro-science activism with the Cornell Alliance for Science, which is particularly important right now in the COVID situation, because even if we get, to give you an example, even if we get a vaccine, if the anti-vax lobby is successful, then not enough people will take it to get herd immunity. So we've got to keep sort of fighting the battles for science and evidence, across the world, because we're currently in a dangerous situation, I think, where fewer and fewer people are trusting science, trusting evidence and expertise, and more people seem to be going for populism and conspiracy theories.
Yeah, I know you've had kind of a hand in a lot of different advocacy issues and I guess environmental issues over the years. How did you end up focusing primarily on climate change?
Well, I don't know. Climate change was my earliest interest, actually. I remember even when I was doing GCSEs, so back in, 1932 or something. I mean, a long time ago now. What am I, 47? So I was probably in the late 80s. But I remember doing a project on greenhouse effect, as it was called then. And I launched my kind of freelance career around climate and writing my first book, which was called High Tide. And that was this. I started doing that back in 2000. And I was traveling around the world. I went to Alaska. I went back to Peru. I went to Tuvalu, looking at, the impacts, visual impacts of climate change and how people are experiencing them, which at the time was novel, but believe it or not. Now this stuff's in the papers every day. But at the time, people didn't believe that climate change was actually happening. There was something which was possibly going to happen in the future. So yeah, that's 20 years ago now.
All right. Well, speaking of which, let's dive into your new book, Our Final Warning. Maybe you can kick us off with kind of a quick summary of what you say in the book, maybe particularly focusing on kind of the 4 to 6 degree warming scenarios, which I think will have a kind of newer ideas for people.
Okay, well, I mean, the book is really just a structure. I mean, I conceived and wrote it actually as a giant spreadsheet, really, where I'm putting together everything in the climate impact literature and attaching it to the relevant degrees of warming. So I can answer the question of what happens at 2 degrees. Actually, what happens at 1 degree is what we're seeing around us, because we're already in the 1 degree world. So we can talk a bit more about that. And also just to tell the story of what happens if global warming is continues to accelerate, and then we don't succeed in mitigating it. And we get, if we go rocketing past 2 degrees, even 3 degrees, where we end up and what kind of world we would be inhabiting from. Well, so you mentioned 4 to 6 degrees. I mean, this is a world where it becomes too hot to biologically for humans to survive in substantial parts of the tropics and subtropics. So North Africa, the Middle East, South Asia, so that's India, Pakistan, Bangladesh, parts of China, Indonesia, which coincidentally all these areas host the majority of the world's population currently. And it would be biologically intolerable. It becomes, basically we've begun to make a large area of our most populated area of our planet uninhabitable. And at the same time, we lose a lot of food production, again, because crops can't survive either in these kinds of heat, and also the drought associated along with it. But we'd long since have lost the Arctic Ocean ice cap, most of the world's mountain glaciers, and a good proportion of the species that currently exist on the planet alongside us. So it would be well into a sort of geologically defined mass extinction. How's that sound?
Was that talking about all of the 4 to 6 range, or were you thinking that was more at the top of that range?
No, that's not at the early. It's at the bottom.
Okay, that's the early part.
Okay. All right. Well, maybe scare us some more with what happens at 5 and 6.
Well, I mean, It's difficult to know for sure because a lot of the computer models don't go up that high, because I don't know why not really. It's almost like the scientists don't even want to know. So I ended up a lot of, in terms of the research for the book, looking at paleoclimate, so looking back at previous what's called megathermal, so really hot house periods in the Earth's geological history. And these were times when there was no ice on the planet at all, when CO2 levels were much higher. There's even, you can go up to places of the high Canadian Arctic, and there's fossilized trees, so there's actual forest growing, and on Antarctica as well. So a completely different world, really, which is difficult to imagine human civilization surviving in. I mean, most of the seas were too hot, so there were mass extinctions. So a lot of the previous big 5 mass extinctions that have happened have been associated with very rapid degrees of warming. And it's possible, if we really were really stupid, to begin to extinct life on Earth completely. This more or less it's like a Venus effect. What happened to Venus is that the greenhouse effect was, well, because it's closer to the sun, obviously, the greenhouse effect sort of went on uncontrolled, and the oceans essentially boiled off, and then you got left with a dead planet. And some of the computer models, it's interesting to see how, if we burned all of the fossil fuels on Earth, so drilled out all of the oil and gas and dug up all of the coal, I think we would be perilously close to that kind of a scenario.
Okay, so I think we're going to return to the possibility of extinction and the idea of, large swaths of the Earth becoming too hot for humans. But before we do that, just covering the sort of current landscape, so far, how much do you think we've reduced expected warming based on our efforts so far, relative to if we'd, really done nothing?
Yeah, well, we're not quite on a do nothing, business as usual trajectory as was, seemed possibly as a worst case scenario 10 or 20 years ago. Just in the UK, we've more or less stopped burning coal in our electricity grid, which is, that's the first time since the Industrial Revolution that the UK hasn't been dependent on coal burning. What we need now is for China and India and other countries which are still on the upward trajectory to get off coal earlier rather than later. But these, the worst case scenarios which take you to a 4, 5, 6 degree outcome require us we'd have to burn like 4 times as much coal as we are doing today. So there's no peaking in emissions really throughout the whole century, which is, how realistic is that? It depends really on your reading of politics. There's plenty of coal out there to burn. So it's really up to humanity how far we want to push that lever, if you like.
If kind of we did nothing, or like nothing more, at least than we're doing right now, I guess how likely are these kind of high degree warming scenarios? I guess maybe I'm thinking more about what's our uncertainty about what's the term for it, the kind of the climate elasticity or the temperature elasticity to carbon dioxide.
Well, the thing is, it's not about doing nothing; it's about doing something, and doing something is burning hundreds of gigatons of carbon, which would be an active choice for us to make. One of the interesting pieces of research which was done, I think it was a couple of years ago now, a paper published in Nature, looked at the current infrastructure around the world. So all of the stuff, the industry, the cars, the power stations, all of that stuff which has already been built, if it operates to the end of its lifetime, what would be the resulting cumulative carbon emissions from that? And it's about, 450 gigatons, which is the entirety of our 1.5 degree budget. So we'd blow through that in 10 years. And so it is unlikely that we'll be able to get back onto that scenario. And if you say, okay, well, we're going to accept 2 degrees as a result, well, that's when you lose the Arctic Ocean ice cap. That's when you see another 10 million people flooded by sea level rise. That's when you see droughts and heat waves really becoming lethal across, large areas of the world. So so my point is really that it's not the 3 and 4 degrees that we should be scared about. It's the difference between 1.5 and 2, and that's where I'm really focused.
What are some of the potential feedback loops that you're most worried about and think that people should be aware of, like positive feedback loops where, warming causes more warming?
Yeah, and so positive feedbacks are kind of wildcards in the system, in that it then the result doesn't become immediately dependent on our emissions. It becomes dependent on other things, so kind of positive accelerations, if you like. And there's different kinds of feedbacks. One of the best known, I think, and most likely is that as you melt the permafrost in the Arctic, so all of that frozen ground, it basically rots and releases both CO2 and methane, which is a much more powerful greenhouse gas. And that then, of course, delivers an extra jolt of warming into the system, which could then melt more permafrost. And so, there's a sort of element to which it becomes a sort of reinforcing spiral. Another slightly different feedback is that if you remove the Arctic ice cap, so all of the sea ice that's at the North Pole, basically, in the summer months, the sun's heat, well, the sun's radiation that was otherwise being reflected by that very bright, shiny ice gets absorbed by the ocean. And that's quite a significant change in the Earth's energy budget. So it's a bit like, if that happens for 2 or 3 months, it's a bit like fast forwarding global warming by another quarter century. So this is why I keep saying that we need to stay within this 1.5 degree trajectory, because the further you go past it, the more likely some of these feedbacks are to happen, and the more difficult it then becomes to restrain the ultimate warming outcome.
I guess also as you go past these much more studied scenarios, you get a lot more uncertainty about whether there are any feedback loops that can be triggered. So it's like more possible that there could be these really bad outcomes that we don't foresee.
Yeah, that's true. We don't know really at what level the Amazon rainforest ceases to be viable. And there's been different estimates of that in the literature over the last 10, 15 years. It was thought to be 2 degrees for a while, then 3, and then 4, and now it's gone back down to 3 or even 2 again, And there's also the issue of direct deforestation. You've got obviously an idiot president there at the moment who wants to deforest as much of the Amazon as possible. And we're already perilously close to the possible tipping point where that ecosystem becomes non-viable. Because once you remove a certain proportion of the forest, you don't get the rainfall anymore because the trees aren't transpiring the moisture that's needed. And if you add some warming into that picture, you potentially get a sort of accelerating drought or even a catastrophic fire season where most of the forest actually burns, which is one of the sort of scenarios I paint in the book, which is, scary, not just for the climate, but, there goes up in smoke a substantial proportion of the Earth's biodiversity.
So talking about our uncertainty at how things are going to go at these higher levels, it seems like one point that people have emphasized a lot, and very rightly, is that there's scientific consensus that climate change is real and man-made. So I looked a little bit into, what the scientific consensus seemed to be on, what would happen at some of these higher levels of warming, and, how much temperature rise is expected from different levels of emissions, especially at these higher ends that you were talking about before. And I realized that there's still a lot of uncertainty, or at least I think there's still a lot of uncertainty on those questions. So I guess I have a couple of questions for you about that. One, why do you think that is? There doesn't seem like there's been as much scholarship on some of those more extreme scenarios. And then also, given this uncertainty, do you think it's possible that we'll be wildly wrong, like climate change could be way, way worse than we think it's going to be, or less bad?
Well, uncertainty is uncertain, rather by definition. So it can be, it's often quantified to the extent you get a kind of probability, I think it's called probability density function, a PDF, one of those sort of it looks like an upturned bell, but with a fat tail at the end. And the fat tail is the sort of the extreme outcomes type probabilities. And so it could even be higher than 6 degrees. But, so I actually do try and quantify that in the book a bit, in the 6 degree chapter, and talk about what the likelihood is if we do continue to increase our emissions. I mean, what are the scenarios where we could actually deliver a really serious collapse of civilization, mass extinction type outcome? And I come in that it's somewhere between 1 in 100 and probably 1 in 10 even, if we're both unlucky and stupid, which is, you wouldn't go on a plane with that level of probability of it crashing, but we somehow seem perfectly happy to tolerate that for our home planet, which is says something strange about the sort of collective, diffusion of responsibility that we seem to be able to feel when it's something that affects all of us. We don't take individual responsibility. So I don't know. There's always a chance it could be much worse than you expect, but there's also a chance it could be much better. At the moment, the rate of warming, planetary warming, is more or less as the models projected, and have projected more or less consistently since the 1980s. So, the scientific consensus seems to be more or less at the moment being borne out by what we're seeing.
So just to make sure that I have what you said, did you say between 1 in 100 and 1 in a 10th chance of societal collapse or extinction if we get to 6 degrees, or all things considered?
No, well, I think societal collapse and extinction would happen a good deal earlier. I think that's a significant risk at 3 and 50-50 odds on at 4 and highly probable at 5 and almost certain at 6. But, that kind of stuff is always speculative. I mean, it could be better than you think. I mean, for example, even though we know that extreme weather events are getting worse, so you're getting more extreme, you're getting heavier rainfall, stronger hurricanes, fewer people die in them. And that's because we've got better sheltering arrangements, better evacuations, more warnings, that kind of things. So it doesn't necessarily follow that because weather's becoming more extreme that it kills more people. And so there's always the human adaptation aspect of things, which means that you can't just make linear projections for where things are now and where things then end up with a certain amount of warming.
Something that was new to me in the book is that you think that kind of scientists or people at the IPCC, they seem reluctant for some reason to truly analyze the kind of 5-degree or 6-degree scenarios. And for that reason, the research on it is a bunch hazier, and you kind of had to do more of the legwork there yourself. Why do you think it is that they don't want to talk about those possible outcomes?
Yeah, again, I can only speculate, but it did definitely jump out at me from the literature was just the absence of study on what the 5-degree or 6-degree worlds would even look like. It's hinted at in some of the paleoclimate stuff, like an introduction to a paper on the end Permian mass extinction might say, well, this bears some resemblance to possible end of the century scenarios, but that's as far as they'd go. And given that 6 degrees has been in the sort of modeling envelope since the 1990s, I think it's extraordinary that scientists haven't put more effort into actually telling us what the worst case scenarios might look like. Given that they've spent, there's probably thousands of papers about 1.5 degrees, which is equally unlikely given how much emissions are still rising every year. So it's like nobody wants to tell a really bad news story, I think.
I guess I could think that we have time before then to think about those worst case scenarios. I mean, I'm not saying this is like necessarily a good reason because, of course, you think it's action relevant now what the worst case scenarios are, but they might think, well, we'll do that next year.
Well, scientists aren't going to think that because they know that the eventual warming is a function of cumulative emissions. So it's a budget, and you can rocket through the budget in the next 2 or 3 decades. So it's not a case of like this is the mistake we make when we think about emissions trajectories in terms of percentages. And you think, oh, well, we'll be 70% below where we are in 1990 level. I mean, all that stuff is actually a distraction. It doesn't tell you anything about where you're going to end up in terms of the resulting warming. But I do think there's a kind of scientific reticence. That term was actually used by Jim Hansen, who's now retired, but he was with NASA for a long time and one of the best known climate scientists around the world. And he spoke about that too. And I think scientists don't want to be called alarmists. They've got to think about the next grant funding. It's a very politicized issue, particularly in the US. If you get a reputation for being an alarmist climate scientist, that might well harm your future career prospects. So, and also scientists by nature are very cautious, don't want to say something which is, which seems extreme and seems ill-considered in some ways. So I think that the idea that some skeptics have that the scientific community's ringing alarm bells all the time is really the opposite of what's happening. Most of the time, the scientists are quite reluctant to say anything which goes beyond what they're most confident about.
Yeah, I understand the reasons. It does just seem to me incredibly negligent because if you kind of add together, well, sometimes people say uncertainty is a reason not to do very much, or they imply that. In the case of climate change, it just seems like uncertainty is an absolute curse for us because once you add together like our uncertainty about how many emissions we're actually going to produce over the next 100, 200 years, and then put on top our uncertainty about how much the climate responds to those emissions, and then add on top X factors that are unknown or, these positive feedback loops, the kind of the tail issue, the probability of getting 5 or 6 degree warming just doesn't seem that low. And I think even in the IPCC reports, they don't say that it's especially low, but then they just don't want to follow through on what that implies about what we should be looking into and how worried we should be.
I couldn't agree more. And in fact, again, I'd say that in the book because if you think of how many billions of dollars get invested in trying to make aircraft that little bit safer, that might save a few hundred lives a year at the absolute most in terms of the numbers of plane crashes there are or would have been with slightly less safe aircraft. And we won't invest even 1/100th of that in answering the question of what the worst case outcomes could be for the planetary biosphere. So it is extraordinary. I completely agree.
I feel like one thing that feels relevant to me here is that a lot of the worst effects would affect future generations, whereas, in the case of the plane, these are going to affect people in the next 5 years, 10 years. So it seems like on the one hand, people are less likely to worry about effects on future people than they are on present people. But I guess I also feel unsure about how much some of these effects of climate change are likely to affect people who are alive today. Do you have a sense of that?
Yeah, well, I think people are reluctant to face any dangers which necessitate a change in lifestyles, however immediate, actually. I don't think it's a case of just kicking the can down the road to the next generation. I mean, you can see that with COVID and with how reluctant political leaders were and societies and people generally to even adopt the smallest changes like wearing masks and things. People are very reluctant to do anything which changes their daily lives.
Although we were much less reluctant when it came to COVID. I mean, the sort of amount that people have changed their lives in response to COVID is much greater than in the case of climate change.
Well, it's proportionally greater, perhaps, to the speed at which the danger becomes apparent. If you can be infected with something in the next 5 days and dead within, 3 weeks, then yes, it's obviously a bit different to a 30-year trajectory where you're not really certain about how you personally will be impacted by something like global warming. But that's why I wrote the book, to try and bring home these impacts and to make it clear that nobody is spared if we allow the climate damages to carry on accelerating.
So I guess you say nobody is spared. What about people who are middle-aged today? Are they spared from severe impacts? Yeah, or there's only, if there's not going to be severe impacts in the next, let's say, 40 years. I'm just curious if you think, in fact, there is.
I don't know. We're seeing fairly extreme impacts already. If you lived in Australia last summer and the sky was red and your house was in urgent danger of burning down. So in California, I mean, a whole town was wiped out, ironically called Paradise. And there was, I can't remember the death toll, but it was in the hundreds. And so there's a non-negligible chance that you will even be killed by climate-related impacts in today's world, and that's obviously going to carry on accelerating. The thing is, people's lives are full of risk, of course. Every time you get behind the wheel and drive, or pretty much everything you do, or whatever you eat, maybe that's going to raise your risk of cancer or something. Not eating will raise your risk of starvation. So either way, you've got to do something. And so we're all used to kind of juggling different types of risk. And yes, I guess I'm sure you're right that risks which can be put off and into a long time in the future are less likely to engender a sense of sacrifice today. It's a bit like, would we all go into lockdown for a pandemic that was going to happen 30 years in the future? Probably, all right, probably not.
Might be a tough sell.
Yeah, but that's why we need scientists to inform policymakers so that we can actually make collective changes, and they don't have to be sacrifices either. This is why I support nuclear power and things which can actually continue to deliver large amounts of energy and modern lifestyles that we all say we want without frying the planet. So, you've got to try and think of a way through that's going to allow us to solve the problem in a politically realistic sense.
I guess one generic concern I have as a consumer of the science here is that, I suppose this is a bit ironic given that I was saying that I wish scientists would be more alarmist in some ways, but I worry that the literature might be a bit biased towards worrying more, because if you're a scientist studying climate change, you're almost certainly worried about it yourself, and you'd kind of rather publish another paper that suggests it's a problem that we need to do something about it, rather than one that suggests that, well, maybe it's not actually so bad and people shouldn't worry as much, because that kind of feels irresponsible. It feels negligent to kind of calm the public down about this. And I guess we see this kind of publication bias in social science all the time, where the more you study a question, the more it seems like the thing that people were saying was the case just becomes like the effect becomes attenuated. Do you worry that there could be biases in what kind of things get published in earth sciences about climate change?
I think, yes, there's probably a bias towards not publishing papers which simply confirm the null hypothesis, i.e. you actually have something worth saying. I mean, a lot of the time when you carry out a scientific study, you find out that your hypothesis was wrong and actually nothing's happening or nothing interesting is happening, but you don't publish those. So, I mean, this is actually more of an issue in medicine, isn't it? Where if you're doing a drugs trial and you find out the drug doesn't work, you don't publish, which is why they've tried to combat that, because that then does lead to a bias throughout the literature in terms of how it reflects reality, if you like. But I think there's probably that in climate as well. But I think it's probably counterbalanced by what we talked about earlier, which is the reticence to look alarmist as well.
I think Rob was asking, correct me if I'm wrong, not about papers that confirm the null hypothesis or like what we sort of already thought or something, but things that actually disagree with other papers that say that it's less, maybe we're going to see less warming from a certain degree of emissions.
Oh, you mean in terms of kind of challenging groupthink?
Well, not necessarily calling it groupthink, but just coming to a conclusion that should make us less worried about some climate outcome than, we would have been just based on the scientific consensus before the study.
Yeah, no, I don't really think so. Having seen scientists in action, as I'm sure you have as well, they love to disagree with each other. They love to undermine and challenge each other's work. And I think that sense of, and even on the most finicky point as well, So you often see, don't you, letters into the journal, the next, they've got some calculation wrong. So I think actually, and there's so much diversity as well. I mean, take the work of Roger Pielke Jr., who's spent much of his career actually trying to normalize hurricane damages and try and find out whether there's a climate signal in the amount of damage that's being done in the US or elsewhere from hurricane impacts. And find out if you account for economic growth and the more infrastructure in coastal areas, actually there isn't a signal that you can see. Does that gets picked up by climate deniers and go, look, hurricanes aren't getting worse, but it's not even saying that. It's actually saying hurricanes might well be getting worse, but that signal isn't coming through with damages once you account for economic growth. So that kind of work actually, which I think is really rigorous and goes counter to the kind of conventional green. You know how hurricanes were sort of adopted along with polar bears as sort of the emblem of a climate impact. I think there's a lot of challenge to that kind of thing, and it's very healthy in scientific sort of discourse that happens.
We'll come back to solutions later on, but I'm curious just to ask at this point, what do you think are the most useful things that humanity has done to reduce climate change so far? Is there a kind of a handful of stuff that's really moved the needle?
That's a really interesting question. Well, I mean, the invention of nuclear fission was probably a key one. It wasn't intended for that. Obviously, it was intended to make bombs initially, and then was intended to make electricity, and was always seen as being environmentally terrible. It turns out that's not the case, and that will, and we're sure we can talk about this, require a sort of ideological mind shift amongst environmentalists more than anyone. But we have made great strides with renewables. Bringing down the cost of solar panels means that solar is now probably the cheapest technology in most developing countries, which means you can get quite rapidly to zero carbon electricity in many places that don't even have access to modern energy at the moment, which is great. We've got lithium-ion batteries, which allow the electrification of a lot of transport. I've got an electric car. That wouldn't have been possible even 2-3 years ago to get the kind of mileage that it's now delivering. And so you can sort of see the contours of a post-carbon landscape, which wasn't the case when I started out. You kind of had to just believe and hope that, that things would be invented which now look like they can be part of the solution.
Yeah, that feels like a really important step forward if it's like we don't just have hypothetical technologies, but have actual technologies.
Hydrogen has always been an example of a hypothetical technology. There's been the hydrogen economy has been a sort of expected by enthusiasts since the 1970s or maybe even earlier. And it's never, it's not happened yet. The cheapest way to make hydrogen, in fact, the way that almost all hydrogen is currently made is through reforming natural gas. So stripping the H out of CH4 and releasing CO2 as well. So it's not even, most hydrogen isn't even green. It actually is a significant producer of greenhouse gases. So you've got to do better than that. You've got to produce hydrogen from zero carbon sources, and you've got to do so more cheaply than it currently comes from fossil fuels. So the economics, the physics isn't really the issue a lot of the time. Having the technologies actually invented, it's often the economics of making sure that they are cheap enough to be scalable outside the lab.
One thing that maybe separates me from the people I speak to who think that we shouldn't do that much about climate change is that I think that we could probably largely prevent climate change without it being that costly, just on a global economic scale. Because we have these technologies now, like nuclear, like solar power, wind power. I think if you just try to add up the total cost that it would take to replace most of the coal power generation that we have with renewable technology, I guess also just projecting forward the improvements or the cost reductions that we're going to get in those technologies over the coming decades. It seems like we can do this for like 1 or 2% of GDP per year over a couple of decades. Does that kind of seem right to you, or do you think it might be more expensive than that?
It's certainly more expensive than that if you go for 100% renewables. But I'm not even sure it's physically possible with 100% renewables. I mean, I've spent the last couple of weeks actually looking at some of the figures on this. And, if you have to try and just replace oil in a country like Korea or Japan, so a densely populated country without huge amounts of spare land, you have to take up a significant proportion of the entire nation with solar panels. In the UK, I just did the figures about an hour ago, actually. If you want to replace our oil consumption, you'd have to cover over 1.5 times the size of Wales with solar, just for oil. And never mind about decarbonising the electricity grid and all the rest of it. So that's not going to happen. It's not going to happen for political reasons. It's not going to happen because of land use conflicts. It's not going to happen. Even environmentalists are against it. Greenpeace was against the latest big solar project in Hill, which is 350 megawatts in Kent, because they say there's better alternatives. I'm like, what are they? If it's not solar, which should be campaigning for 3 decades, in favour of rather for 3 decades, what's the alternatives? nuclear? I mean, you're going to change your mind on that? Magic? Tell us which one. So, we've got to get to more numerate, to quote David Mackay, the late great David Mackay, approach to these kinds of issues. And to come back to your point about economics and spending, the oil industry plans to spend, I can't remember exact figures, but it's trillions in terms of oil exploration and production in future decades to keep the world hooked on liquid hydrocarbons. We're currently consuming close to 100 million barrels of oil a day. That doesn't just come from nowhere. It costs a huge amount of money to explore and produce that. And so that's money which could be being redirected into not renewables only, but clean technologies across the board. And it's certainly possible that those could be delivered at a net zero cost. So it's as cheap as keeping oil free. And certainly I don't think it's going to bankrupt the world to get off carbon.
Yeah, so I think I meant to talk about the net cost, and I think that's something that people will maybe miss, is that we already spend a lot of money, replacing electricity infrastructure, going and exploring for oil and getting the oil and building all of the plants to generate this electricity. And I just want to think about what's the incremental cost to do that in such a way that we don't produce terrible climate change. And there, if you think about that, it's just like, this seems like well within humanity's economic budget to do this. It just doesn't. I don't think it's going to break the bank.
It might well be. So if you include nuclear and if you get nuclear to be cheap, which means you'd have to change the whole nuclear production process and make it modular and make it scalable, rather than having these great big concrete, first of a kind projects which cost tens of billions. But if you can do that, and I don't see any fundamental physics or engineering reasons where you can't, you could probably deliver net zero carbon at net zero cost. That's my guess anyway.
So, as listeners can probably tell, Rob and I, and 80,000 Hours more generally, are pretty concerned with climate change and, also very concerned with the possibility of extreme impacts, which might make people who are longtime listeners to the show or familiar with us wonder why we don't talk about it more on the show or on the website. So, we're actually in kind of a tough spot when it comes to climate change and how we should talk about it. So relative to a lot of people, we're more concerned about climate change because we see it as having these tail risks, these risks of extreme impacts that could decimate the future of humanity, and also because, we care a lot about long-lasting impacts that can last, indefinitely into the future and not just things that happen in the short term.
And there's also just so many cool concrete things you can do. So, electric cars, build nuclear power plants, advance to solar R&D. Personally, I find it really, really motivating that it just seems like it's a problem that we really could solve if we put our minds to it.
Yeah, so, there's all these reasons to focus more on it. But then, on the other hand, it doesn't sort of make this very short list of top problems that we talk about the most. And that's for a couple of reasons. First, it's already among many people's greatest concerns. So I saw a survey recently that said that climate change and environmental destruction were rated by millennials as the most critical problems to solve in the world. And because we're, a really small group and we're advising a comparatively small audience right now, we think it makes sense for us to focus on issues that are more neglected. So that's including issues that receive, less than 1% of the funding that climate change does. And we do that because we hope it means that people will be able to make more progress on those issues where there's more low-hanging fruit. And secondly, while we agree that climate change is likely to be very bad and maybe even going to be an unprecedented humanitarian disaster if we don't, do something really quite drastic about it, we think it's unlikely to lead to a collapse of civilization or human extinction. And insofar as that's the case, it seems less likely to permanently affect humanity's future for the much worse. And at the same time, we think there are issues that do have the potential to totally destroy humanity's future. And some of those are much more neglected issues. So we think it makes sense for us to suggest that many of our audience members work on those right now. Do you have any just reaction to that general take?
Well, yeah, there's a weird sort of disconnect really between a lot of people saying that humanity's number one challenge is climate change, while at the same time it's never your number one concern on any kind of day-to-day level, or even on the list of political concerns. It's now in the top 10 for most people's political concerns, and has even been a major factor in elections in some countries, but it's not really dominating the agenda in a way that, that would be necessitated if we were to really deal with it seriously.
Yeah, it's interesting. That seems right. But where do you think this disconnect comes from, where a lot of people say, this is the most important issue facing the world right now, but then it isn't at the top of political agendas?
I think it's because it's perceived as being hard. It's not an easy thing to tackle. It's perceived as being the property of a particular political constituency, mostly the kind of the left and the Greens, and everyone knows they're a bit mad, and so it's seen as being a really expensive and really difficult thing to do, which is going to potentially, for politicians, lead to short-term political pain. And you can see why that is. I mean, take Germany, good case study for how not to do climate policy making. And the unfortunate thing with Germany is that they've got this combination of two really critical problems. One is that they're highly dependent on coal, and the dirtiest form of coal, brown coal, lignite, is mostly extracted through open cast mining. So tremendously damaging to the landscape. They're eradicating old growth forests and medieval villages, and it's just terrible. But there's a very strong coal lobby, which is, this is an industry which employs tens of thousands of people and has very strong union representation. So politically, it's a very powerful voice. So that's number one problem. Number two is that this is a country which is, for one reason or another, has become almost existentially angsty about nuclear. And the Green Party, which I think first came to power in Germany in 2000, came on a platform of getting rid of the nuclear power stations. They didn't care about climate change, and they still don't, to anything like the extent that they care about getting rid of nuclear. And so what's that meant? It's meant that they are going to keep coal on the grid until, I think the latest political agreement was 2038. So all these things are always a product of different political forces and cultural forces, and every country is a bit different. But it's not just the obvious conventional bad guys like ExxonMobil or the sort of big names of the fossil fuel industry who are standing in the way of progress. It's also Greenpeace. It's also ourselves in terms of our own biases and lack of ability to change our minds on key issues as the facts change.
I'm not sure whether this should make us more optimistic or more pessimistic, that it's kind of an issue that's gotten a lot of attention for decades, and the vast majority of people think it is a real problem, and a decent fraction of the population thinks it's the most important problem, and yet there's so much that hasn't gotten done. On the one hand, that could make you think, wow, there's so much potential to do much more than we're doing now. On the other hand, you might think, well, even if we do convince even more people that it's the most important problem of our time, just nothing will continue to happen because there's some other barrier or some other bottleneck.
Yeah, but that's because the problem isn't solvable with the conventional green prescription. So it's hardly surprising that it doesn't get solved. They say you've got to solve climate change with only using wind and solar, where they themselves admit that wind and solar, well, they're even against them when they're proposed. So it becomes then an insoluble problem, which is why then it doesn't get solved. I know it's not difficult to understand. So the kind of the conventional narrative of we would have solved this 30 years ago if the bad guys in the fossil fuel industry hadn't stood in our way, I don't think it's quite right. Actually, and I wrote this in my Nuclear 2.0 book, I blame the green movement for at least half of cumulative emissions. If the nuclear power build-out programs which were proposed in the 1960s and 70s had continued, then most of the world's electricity would probably be zero carbon already. And we'd only have to worry about the rest of it, the liquid fuels and stuff. And you can see that process taking place in the US, where the anti-nuclear lobby stopped power plants, which were then converted to coal. I mean, they just took the reactor place hall and put a coal furnace in there, and the environmentalists all went away and said, off you go. And that happened over and over and over again. And they made the world safe for coal. That wasn't the intention. It was all meant to be fluffy wind and solar, even back in the 70s. But physically a challenge now, but it was physically impossible then to do what they were asking for. So whose fault is it? I'm a green. It's my fault too. I was anti-nuclear for all those years as well.
All right, we'll come back to the nuclear issue later on. We've got a pretty big section on that because I really liked your book, Nuclear 2.0. But for now, let's dive into this issue of how likely it is for humanity to be able to kind of avoid the worst possible outcomes of climate change, which is an area where I think we might disagree on the probabilities. So I guess, yeah, just recap us overall. How likely do you think it is that climate change will lead to kind of the breakdown of industrial civilization as we know it today? And I guess secondarily, how likely might it be to effectively cause human extinction? And I guess probably those numbers are going to be pretty different. They're two fairly different standards.
Yes. Well, for me, the question isn't quite in the way you framed it. The question is, at what degrees of warming do these outcomes become more likely? And I remember when Extinction Rebellion sort of spokespeople were on the media saying billions are going to die in the next 10 years. And I think it was Andrew Neil actually in the interview said, well, how? What's going to happen? How do we kill these people? And they weren't able to answer. So it's one thing to have a kind of apocalyptic fear, and another to actually try and think through what the mechanisms are which will actually kill people, if that's what you're concerned about. kills people, thirst kills people, war kills people, hunger kills people, people die because of lack of shelter. So it's different degrees of civilizational collapse. I mean, conflict, war is a civilizational collapse in a way, particularly if it's potentially worldwide. So for me, I think the most concerning scenario is one where you can't produce enough food to sustain the world's population, which is a lot higher, remember, by 2050. The latest UN figures are 9.7 billion by 2050. So you have to pretty much double the world's food supply at the same time as you've got less and less of the world's land being able to produce because of the combined impacts of heat and drought. And obviously plants can't grow without water. Also, plants can't grow if it's too hot. I mean, you can push the thermal tolerance threshold of crops with genetic engineering to some extent, but there comes a point where enzymes get denatured and your plant will just die, or certainly, and there's a long time before that yields will fall off and so on. So that's for me the main question. And one of the most important studies I think that's ever been performed on this was a study in PNAS journal, which looked at what they called synchronous collapse in bread baskets around the world. So at the moment, the world still produces enough food every single year, very reliably. We've never had a major food shortage, which has been as a result of harvest failure. So, I mean, if the US Corn Belt was knocked out one year, that would have a huge impact on food prices and have a huge impact on food security, in fact, as a direct result of that. But imagine if it wasn't just the US Corn Belt, it was Australia, it was Brazil and Argentina, it was, bread baskets of Eastern Europe and the former USSR, all of that added together, then you're into a situation which humanity's never experienced before and which looks very much like famine. So that, for me, that's how I answer the question, how are people going to die? People are going to die from starvation if there isn't enough food globally. That's one of the mechanisms. And when that happens, you can actually link with some degree of confidence to levels of climate warming.
So you said you wanted to, the way that you prefer to think about this is in terms of which temperature increases give us a good chance of these kinds of impacts. So do you have a guess at what degree of warming we would need to reach for the sort of full-scale collapse of society, perhaps due to, very, very widespread famine, to have, say, a 10% chance of happening?
Oh, I think you want to put me on the spot. I would say it has a 30 to 40% chance of happening at 3 degrees and a 60% chance of happening at 4 degrees and 90% at 5 degrees and 97% at 6 degrees.
Okay. Now, I appreciate you being willing to put numbers on this because I feel like that's always really hard, but it's really helpful.
And maybe a 10% to 2 degrees. So
okay. So we're getting close to 10% already.
Yeah, but I think these early stages of warming, I mean, we're at 1 degree now, and obviously it hasn't happened, so that's a 0% chance of civilizational collapse unless it starts happening tomorrow. But, the biggest impacts now have been on natural ecosystems. Remember, we lose 99% of the world's coral reefs before 2 degrees. So that's an entire biome wiped out. And the same happens with rainforests and, other important ecosystems, the whole Arctic tundra and so on, fairly early on. And so humans are actually, obviously, and this is a bit of a truism, I mean, we're a remarkably adaptable species. We've got all sorts of tools and technologies at our disposal. I mean, we can even de-link food production from land by using microorganisms in industrial vats. You have to have feedstocks like hydrogen and CO2 to put into those. But, then you've completely de-linked food production from climate. So this is why I wouldn't put 100% risk on civilizational collapse, because there's always the possibility that we can adapt our way throughout almost any imaginable scenario, with the exception of turning the planet into Venus. But even then, I suppose we can go off and terraform Mars, I suppose, and maybe a few hundred people do that for a couple of decades until it doesn't work out. I don't know. I'm indulging in spurious speculation there, but where does the synchronous breadbasket harvest failure come in? About 4 degrees. Where does the sort of this issue of biological uninhabitability of large areas of very densely populated parts of the world? That's about 4 degrees as well. So that's why the numbers really go up at that level of warming.
Okay, can I ask another really hard question, asking you to put numbers on some things, just to get a sense of your views? So that was large-scale civilizational collapse. So longtime listeners will know we're especially interested in extinction risks at 80,000 hours. So can you answer for humanity going extinct? So what temperature are we 10% likely to go extinct at?
Well, to extinct humanity, you have to eliminate the last breeding pair.
Mm-hmm.
So
It's a high bar.
It's a very high bar. People can live in artificial environments given with sufficient food for quite a long time. And we can live in environments which are very, it's not, we can't just say, well, our habitable space is, I don't know, average 14 degrees or something like a particular species of tree or reptile or something. We're very, because of our technologies, we can live in minus 40, we can live in plus 40 Celsius. But I suppose our resilience is comes in the same way as our kind of Achilles heel, in that we are interdependent in incredibly complex societies, which you can't even understand. I mean, they happen dynamically, but no one really knows how the economy works. And so the sort of fantasy that survivalists have of being able to look after themselves and maybe their family in a sort of protected fortress type environment, you can, if you stockpiled canned foods and the zombies don't get you, you can do that for a decade or two. But
then extinction would just happen later if that was all it depended on. Yeah,
but I do think that humans are one of the last species to go extinct on the planet, not one of the first, because it's just obvious. A, there's a lot of us, so to kill us all is going to take some doing. B, we're incredibly adaptable and can live in all sorts of different environments. We've got all of the technologies, and we've also got advanced knowledge of these impacts, i.e., because we're discussing them now, so we can avoid most extinction scenarios if we don't even have to be that smart to do so. So I'm not too worried about the near to medium term prospects of human extinction. Yeah, I think there wouldn't be much of any kind of life left on the planet if humans were to fail to survive as well.
What about the long-term risk of extinction? So let's say if we get up to 6 degrees, do you have a guess at how probable it is that we go extinct?
I think some humans would survive even at 6 degrees. You need to be in a situation where none of the planet's surface is able to produce crops. Even at 6 degrees, you could produce crops up in the Arctic or on the Antarctic Peninsula or in Alaska or somewhere. But if all of those places are too hot, or you have to make the atmosphere unbreathable in some way, so you need to be into a kind of runaway greenhouse scenario where you're sort of gradually transforming towards Venus, and the water on Earth is most of that ends up in the atmosphere and gives you a very accelerated greenhouse effect. That means you have to break down the structure of the atmosphere. You've got to destroy the tropopause, so in the troposphere now, as it gets colder higher up, the liquid water condenses and falls back as rain. You have to stop that process happening so that water vapor can circulate throughout the whole atmosphere, which is probably what happened with Venus. But one of the ways to think about this is, there's this concept in solar systems of the habitable zone. The Earth is thought of as being in this sort of Goldilocks zone where it's not too hot and not too cold. Mars is too cold, Venus is too hot. It's pretty clear that we're very close to the inner edge of our habitable zone. So we're a lot closer to the Venus outcome than a Mars outcome. That maybe wasn't the case in a few billion years ago when we had snowball Earth and the atmospheric chemistry was very different, and the sun was a lot fainter as well. So this combination of a more powerful sun over geological time and the changing atmospheric chemistry means that we're quite close now to the inner edge of what's tolerable. So the additional greenhouse effect that we're creating is a bit like pulling the Earth closer and closer to the sun, in terms of our orbit, which isn't, for me, it's a good way of thinking about it. Every time you switch on your car, you're taking us a centimetre closer to the sun.
So it sounds like we should mostly talk about the collapse of civilization cases because they seem substantially more likely, just because extinction is such a difficult thing to accomplish. But are there any ways in which we could, end up with 12 degrees or 18 degrees warming that worry you, or you think are more than an incredibly low likelihood?
Yeah, but that's in a process of runaway. The surface temperature of Venus is like 400 Celsius, I think, maybe a bit higher. So that by that time, there's no liquid water anywhere, and most of the carbons move from the lithosphere to the atmosphere. So we've got a 95% CO2 atmosphere, I think, on Venus. They're very, very dense, very high pressure, and very hot indeed. It's a long way between where we are on that. And I guess what's also perhaps a kind of guardrail is how hot has it ever been in terms of the geological past of the planet? As an average temperature difference, it may have been in the mid-Cretaceous as much as 10 or 12 degrees warmer than now on average, which is why most life was then at the poles, or certainly in the very high latitude. The tropical oceans were, 40 Celsius or so way too hot for most most life to survive. You get reef gaps in the fossil record where there's no corals, very few marine organisms at all in those sorts of areas. But the Earth survived that before with a fainter sun and with slightly different atmospheric chemistry, with a fully functional carbon cycle. What's perhaps scarier now in terms of a geological parallel is the rate at which we're forcing the system. So, we're transferring carbon from the lithosphere, so from the rocks, the subsurface into the atmosphere, probably at about 10 times faster, so at least an order of magnitude faster than that's ever happened before in geological time, including the mega eruptions which caused mass extinctions. So how well the Earth is able to buffer this very rapid change in atmospheric chemistry and the resulting energy budget, we don't even know from looking at the geological past, because this is an experiment which has never happened on this planet before.
Okay, so it sounds like you think that the two most probable indirect channels by which we could get kind of civilizational collapse is through famine, firstly, and then through war or conflict being prompted by climate change. Is that right?
Yes, I suppose fresh water supplies is another key concern. And that's not just sitting around and waiting for it to rain, but the reality is that most of the world's crop production is rain-fed as opposed to being irrigated. So, and with irrigation, of course, you have to have a natural fresh water supply where you can abstract water from ground reservoirs or from rivers. There's always an adaptive potential there too, though. If you've got enough energy, you can desalinate seawater and produce large quantities of fresh water that way. But again, it's anyone's guess how far that's realistically possible in terms of replacing the freshwater needs of continents which host millions of people.
So is the freshwater, that's mainly one of the mechanisms by which we might get famine, or is there another independent way in which it might lead to civilizational collapse?
Oh, well, I mean, clearly, if there was no fresh water, a city can't survive without fresh water for more than a few days. It's a bit like electricity in that sense. I mean, if you switch off certain things, that's worse even than food. Food, you can, maybe you can survive with a stock for a couple of weeks, but water, much less time, obviously. So, yeah, that's that kind of day zero. I think they were talking about in Cape Town, when their reservoir finally dried up. But I think they'll be better prepared for the next time. So they're obviously investing already in desalination and in more reservoir capacity, further afield and so on. So I don't think there's not like some day of the dead where, we all run out of water at the same time. It's something which will happen in different times at different places if it isn't fixed in advance and if adaptive measures aren't taken.
But you think of that as one of the more worrying scenarios when it comes to sort of indirect ways that climate change could bring about the collapse of civilization?
Well, I think the most unpredictable way is through conflict and refugee flows and things like that. I mean, you just can't. I mean, there's been attempts, for example, to link the Syrian conflict to climate impacts, and there's no doubt that the resilience of societies were undermined in that region due to drought, a really serious drought for the previous sort of 10, 15 years beforehand, which meant a lot of people left the land and were sort of forced to live on the edge of cities as refugees, and the regime wasn't supporting people. And those kinds of conditions lead to popular protests, which then led eventually to the civil war. But that's contingent on a lot of other factors, like the response of the government, which was obviously to try and barrel, bomb and gas people, and led to a kind of a really horrific conflict with a very large number of refugees. It's been different in different countries where if the government falls quickly, then you can get a different government comes in and maybe even addresses some of those concerns. So it's contingent on so many different unpredictable factors that you just don't know. But obviously, if you have a large enough conflict with a high enough rate of mass death from maybe nuclear weapons exchanges or something like that, and you can get large-scale societal breakdown as a result of that too.
Okay, so let's maybe talk about the famine channel first. I'm worried about that, but I think a bit less worried than you. I guess there's two ways or two things that we could maybe look at. One is what's the probability that we have a really big food shortfall? And then what's the probability that leads to some kind of cascading civilizational collapse? Let's maybe do the second one first. So imagine that we do have a whole bunch of breadbasket areas that all have kind of a drought simultaneously. And so food output globally goes down a bunch. Let's say we only have 80, 70% as much food as we have in a normal year. What's the path by which that leads not only to like a lot of people dying of hunger, but it also leads to civilization as a whole falling apart?
It's reflected in prices. So, I mean, obviously that the price mechanism is the rationing mechanism that we have to decide who gets to eat and who doesn't in pretty much every society. And there was some forewarning of this in the 2008 food price spikes, which are more related to the oil price at that time, actually, than any scarcity of food. But I think the same thing would happen. And even then, the food producing countries ceased to export. And so they put on export bans, which then affect the commodities trade. It means that food importing countries experience both rapidly increasing prices, and the result is food insecurity. So if prices double, triple, I mean, you get more than a 30% reduction, by the way. If you lost that much harvest, you'd be down to, you'd lose all of your world food trade. So food importing countries would potentially starve very quickly. And so I think, and people aren't just going to sit there, and gradually get hungrier and hungrier. They're going to move. They're going to, move in their millions to try and find whatever food's available anywhere. And those kinds of dynamic effects, I think, both very difficult to predict, but
don't look good.
No, they don't look, exactly. No, they don't look good. They're not going to have an outcome which means that everything's hunky dory.
So maybe people moving around in order to find places where they can eat might lead to refugees, and that would possibly lead to conflict. But also, is that the idea in terms of, and then that would lead to collapse? I
guess. I mean, it's again very difficult to predict the response of countries which do still have food sufficiency. Are they going to be prepared to share, or are they going to put up borders, build walls? The evidence from the Syrian refugee crisis suggests that the response will be to close borders and build walls and allow people to drown in the Mediterranean in their hundreds, as Europe has done. And, look at the political ramifications of that. You then saw a rise in populist movements and almost fascist type political parties, which are now in power in several European countries, and take us back to a time which is scarier than any since the 1930s, I would say. And this is Syria. This is one country. Imagine this happening across a majority of the world's countries. Then those countries which do produce enough for themselves are really going to have a tough time. So, yeah, we can take glimpses of the future, perhaps, from some of the really awful things that have happened in previous years, but the sort of multi-systemic nature of it doesn't really give you a sense of the magnitude of the result, I don't think.
So when I envisage a situation where there's a huge food shortfall like that, well, firstly, I think we'll probably have some heads up that this is coming ahead of time. You start to notice the warning signs earlier, like food prices going up and food futures going up. And then I kind of imagine that people would start, because this would just be like, it'll be an emergency, a global emergency on the same, like much worse than the coronavirus, say. You just start seeing everyone starts paying attention to how the hell can we get more calories produced. And fortunately, unlike in 500 years ago, we are in the fortunate situation where most people today aren't already producing food, and most capital today isn't already allocated towards producing more food. So there's potentially a bunch of elasticity there where if food prices go up tenfold, that a lot more people can go out and try to grow food one way or another, and a lot more capital can be reallocated towards agriculture in order to try to ameliorate the effects. And you can also imagine, just as like everyone in March was trying to figure out how the hell do we solve this COVID problem, everyone's going to be thinking, how can I store food? How can I avoid consuming food? How can we avoid wasting food so that every calorie looks precious? And maybe that kind of sense of our adaptability or our ability to as a globe to set our mind to something when there's a huge disaster and just throw everything at it, perhaps makes me more optimistic that we'll be able to muddle through, perhaps more than you're envisaging. Do you have a reaction to that?
My reaction is, imagine if Donald Trump is in charge of the response. It's all very well to have sort of optimistic notions of technological progress and adaptive capacity and things. And yeah, if smart people were running the show, that would no doubt be the most likely outcome. But smart people don't run the show most of the time in most places, and people are amenable to hate and fear and denial and conspiracism and all of those kinds of things, as you've seen even in the very short term challenge of COVID.
Yeah, it is interesting. I'm not sure whether to update positively or negatively on society's resilience watching COVID. I mean, there's some places that have handled it, really admirably well, and we've been impressed by how good their governments are. And then other places where it's just been remarkably incompetent. But something that's really struck me is how disruptive it's been to have a virus that, has an under 1% fatality rate, which you think, like in the scheme of pandemics, really isn't that serious. And yet it's just like it threw everything into disarray pretty quickly, which has maybe made me more worried about these kind of flow-through effects and being like, well, if 10% of people are starving, like how much disruption does that create to everything? And I guess the fear of conflict, like how much does that make it hard to get anything done?
Well, and it wouldn't just be a global average of 10%, like you have a global average of 1% for COVID. It would be, I don't know, 50, 90% in certain places. And I think that would be a psychological shock to us as much as anything. Even if you're in a country which is likely to survive, just seeing that extent of famine, would be in a, as you say, we haven't seen anything like that since the medieval times. But yes, society's tolerated with the Black Death, the loss of half of the population across much of Western Europe at certain times. And there were famines which probably had death tolls which were of similar magnitude in those times as well. And what did people do? They worshipped, they they castigated themselves, they fought wars, but they survived. So that isn't necessarily the sort of herald of extinction. But remember, these processes are getting worse unless we've stopped emissions by that time, because the economy just can't. Which I think actually is quite likely. Nobody talks about this. How are you going to carry on burning huge amounts of coal or any kind of fossil fuel if society is so challenged by a mass famine, for example?
That sort of brings me to a question that I wanted to ask you, because, it came up in your book. So when I have thought about whether climate change might cause extinction, and maybe we can come back to this, but I thought, okay, well, what if it warms, 10 degrees or 12 degrees or 15 degrees? Then maybe we see people dying just of heat stress. But then I thought, well, but how could we possibly continue burning fossil fuels over the hundreds of years required to warm the planet that much, assuming that there would be these huge effects before any of that happened? For instance, these famines, and how could people continue to want to burn fossil fuels throughout that entire time? And so that was making me feel more optimistic that we wouldn't get to those extraordinary temperature rises.
So the source of optimism there is that if warming is sufficiently extreme, it will trigger enough societal collapse that there will be lower emissions, and therefore you won't get a runaway feedback effect.
I agree. It's an attenuated sense of optimism. Something like, I was imagining, is it possible to get to these extraordinary levels? And I thought, how could we keep burning until we get there? So yes, in some sense, not necessarily through societal collapse. It could also be through people being like, oh my God, this is having such huge effects. This is becoming so politically urgent that we have to stop burning fossil fuels. So that was the sort of thought.
Great. Well, I'll take comfort from that.
Okay. Well, unfortunately, I'm about to try to. Yeah. So I was, reading your book, and you mentioned that one issue with talking about adaptability is that it's going to be much harder to adapt without burning fossil fuels if we haven't already transitioned into a carbon-free economy. So fossil fuels are the source of our ability to do so much. So maybe people will feel like, okay, well, we really need to just, for the next 5 years, we really need to do this huge project in order to adapt, which is going to require us to use a lot of energy, which is going to require us to burn a lot of carbon, which might make it so that people are more likely than I had initially sort of intuitively thought to continue releasing carbon into the atmosphere, even as things get really, really bad.
Well, that's the kind of Dubai scenario where you have a sort of an oil-dependent, a petrostate under a huge air-conditioned dome in an intolerably hot environment, which is entirely dependent on artificial water, artificial energy generally, and food from elsewhere. So yes, it's certainly possible that whole cities can exist in a ambient environment which is intolerably hot, but you can't do that over an entire subcontinent. You can't build that dome. And the process of, you can see this process already happening with just with air conditioning. So air conditioning demand is one of the biggest drivers of increased energy use and increased coal burning in India, for example, and other places too. So maybe that's a kind of feedback, a smaller scale version of the feedback you're talking about.
Yeah, it's interesting. It'd be like a human feedback loop or something.
I think one part of what Arden's is gesturing at is that if in 50 years' time people see that the world is on fire or things are going horribly because of climate change, some people have the intuition that, won't that cause us to stop burning fossil fuels? Because we'll have seen by that point how reckless it is to do so. But I think that kind of underestimates human stupidity. I'm not very calmed down by that, because kind of the international public good problem will still be there. The fact that the incremental emissions that you do at that point in order to deal with that situation, that's going to cause problems more in the future than it does right away. I could totally imagine a situation where the world is falling apart and people maybe even want to burn fossil fuels even more because they feel desperate to find some way to cope with the situation, and that just makes it worse.
Or they're like, it's already so bad, we might, or there's some sort of defeatism.
What the hell
could happen?
Well, and also it's true now that the higher your level of development and your higher your level of emissions and oil consumption, the more resilient you're likely to be to climate impacts. When the hurricane hits, if you've got a society which has advanced infrastructure and is therefore probably very dependent on carbon fuels, then you're going to have a much lower death rate. So yes, there's already a kind of a conundrum for countries like, I don't know, Bangladesh, that ironically enough, your best way to resist climate damage is to burn as much fossil fuels as possible and to become as developed as possible, as rapidly as possible. And I don't see why that dynamic would ever necessarily disappear unless clean energy becomes cheaper than fossil energy.
Let's return to this famine issue. So it sounded like you thought that in some of these like 3 or 4 degree warming scenarios, we could end up with food production halved or more in a given year, which is perhaps more than a bigger impact than I expected. Yeah, maybe try to convince me of that's how how big the effect could be.
Well, you just need to look at the scale of the issue. I mean, in terms of food production, it's only a few hundred millions of tons which make up the food trade, which is only a few percentage points really of the overall production. So you don't have to lose very much to eliminate all of the traded commodities of rice and corn and wheat and things that now constitute a majority of the calories for importing countries. So you've got this, it's Ricardo, isn't it? Going back to classical economics, you've got this sort of specialization where countries which can produce food do, and then trade it for other things which are produced in countries which have a sort of better capacity to do other things. So, the other thing you've got to think about is to what extent does that drive us into a autarkic sort of production model where everyone closes their borders, you only think about your own population, you ignore famines abroad. There's clearly when politically leaders are responsible to their own populations, that's your main motivator. You don't care whether people are dying in faraway countries. And like I say, that did begin to happen in 2008. The first response was to close borders and to stop exports in order to, both in order to protect the price and to protect supply at home. Because if you're exposed to international markets, then you get increased prices even in a domestic situation where you produce enough food yourself, of course. So that kind of dynamic between globalization and a return of protectionism, I think, would be a huge driver of what actually happened in terms of food security globally.
All right, maybe let's maybe talk about the conflict route. And this is one where I think I just feel more intuitively skeptical about climate change causing wars than many people seem to be. It's something that just a lot of people say, and then when I think about it concretely, I'm like, why would they go to war? So it's like even if you have a famine or even if you have refugees coming across, I could see that causing a lot of political chaos. But perhaps this is bringing out the kind of the rational agent economist training in me, where I'm just like, but going to war wouldn't help to solve those problems. And indeed, when you kind of have a recession or when you have a lot of other problems to deal with, like the pandemic, we have this pandemic, people aren't really talking about going to war because it wouldn't help to solve the pandemic, and it's like very costly while you're dealing with other emergencies. So maybe try to pitch me on the idea that climate change would be has a decent probability of causing international conflict that could really get out of control.
Well, it doesn't have to be international conflict. Most conflicts now are within national borders, obviously. So I think what tends to happen, and there has been some published work on this, is that resource scarcity intensifies intergroup conflict because you get this more of a sort of ethnic phenomenon, really, where certain groups try to monopolize scarce resources within a nation. That leads obviously to conflict and potentially to a kind of breakdown conflict scenario as a result. And those wars can then spill over. I mean, look at Syria. It's not just a civil war. It's pretty much a great power conflict, or certainly was before the US exited, where you've got different powers sort of jostling for dominance within that scenario. You've got Iran, you've got Israel, you've got the US, you've got Russia. It's not just about whether the Syrians have to keep their dictator.
I think some people might think that in order to get societal collapse, and maybe, it's possible we're talking about different things here, but if societal collapse means something like the sort of the industrial economy is reduced by a huge percentage and, the political systems around the world don't work anymore, and, thinking about something that's like very, very widespread and very, very dramatic, such that we might think it could set us up to sort of stagnate for a very long period of time as a species. I can imagine some people thinking that in order to get something like that from conflict, you would need to have, a hot war between large powers in order to get sort of enough destruction to make something like that happen. Does that seem plausible?
Yeah, but I just don't. I can't imagine what the scenario is. It's just you're into science fiction, really. I think all you can say is that when you've got resource scarcity, you've got a higher potential for conflict, given the competition that comes as a result of that, whether that's intergroup within nations or potentially between nations. If you've got conflict, I mean, I don't know, people have been expecting water wars for ages already. And you've got conflicts between, say, India and Pakistan, or currently, I think, between Egypt and Ethiopia over the Nile. I think Ethiopia's just been building a new dam, so that's obviously going to take some of the water from the Nile and affect the amount of fresh water that comes downstream to Egypt. But are they going to fight a war over it? Is Egypt going to bomb the Ethiopian dam? I mean, probably wouldn't be good for them if they did. So actually, a lot of the time, it's better for both sides for these kinds of conflicts to be resolved through negotiation than through warfare. And that's particularly the case when you have nuclear armed states. I mean, I think there's a strong argument that you've had a much lower rate of warfare, interstate warfare, as a result of nuclear weapons than you had beforehand, when the stakes for going to war were much, much lower. And those things aren't going to change. Nuclear weapons aren't going to disappear. So I struggle to imagine the scenario where climate change leads to a kind of World War III, let's say. But in a more unstable, resource-constrained world, I think you could certainly argue that it's more likely to go in that direction than less.
So moving on from the conflict scenario, which it sounds like you think it's a little bit challenging to make the case that it's directly going to cause an international war or like a global power conflict. Just, I think other things that inform my general hopefulness about this, I'm not optimistic about everything, but I feel there's some degree of positivity about this, is that as you were saying earlier, despite the fact that there's more natural disasters now, like the number of deaths in natural disasters is down 90%, even though the population has increased several fold over the last century, which really seems to indicate that, on balance, our ability to adapt and build things and invent things is winning out in that case. And I mean, and natural disasters are only responsible for about 0.1% of deaths over the past decade. So, even if it increased 10-fold or 100-fold, that does seem survivable. And then you look at, people talk about, ocean rising being very problematic. But then you look at the Netherlands and you're like, well, already a third of this country is below sea level, sometimes often several meters below sea level. And the Netherlands seems to be doing fine. They just use infrastructure to get around the problem. And then I think, well, why couldn't New York do that? Why couldn't other, at least rich cities do that? And then you see, I'm hopeful that, in 30 years' time, 60 years' time, more and more places will have industrialized, will have developed, a bit like China, South Korea, like Vietnam's doing now, which will give them more ability to, build the dams that will protect them against sea level rise and to, put more effort into high-tech agriculture so that they can, reduce the risk of a famine. Do you have any, I guess this kind of thing just goes to like a deep kind of worldview about how optimistic you are about human adaptiveness? And it sounds like, on balance, you really are fairly optimistic about human adaptiveness. But yeah, do you have any take on that?
I've become less concerned about sea level rise as a near medium-term serious stressor on societies. Obviously, that doesn't go for small island states. So if you're a coral atoll, you can't build a wall because the water's going to come up through the middle and ultimately the waves are going to wash over your entire land. So, but that's, if you're doing numbers, that's a relatively small proportion of the world's population, well under 1%, I'd have thought, probably much less. It's a few millions of people, really. Big deltas, Bangladesh is a delta, which actually the Netherlands is too. You can protect, and in fact, most of Bangladesh, if you ever go there, is protected by a whole network of dikes and walls and things. So it's they have their own kind of polder system, without which you wouldn't be able to produce nearly as much food or, keep the population as they currently are in coastal regions in Bangladesh. So all these societies are already adapted to flooding and sea level rise. Flooding, by the way, is an issue as well, because if you've got a lot of water coming down in the monsoon season, at the same time as you've got water coming up from, let's say you've got a coincidental cyclone and a higher sea level as well, it does become difficult. But I mean, there was 170,000, 200,000 people killed by cyclones in the 1970s in Bangladesh. That never happened. You're very unlucky if you get a death toll over 100 for a cyclone of the same kind of intensity. So it's down by much more than 90%. It's orders of magnitude in terms of how likely people are to be able to survive even increasingly extreme natural disasters. So that's good news. And in terms of sea level rise, it's just very slow. Nobody has to drown when sea levels are rising by, even if it's a centimetre a year. It takes, you're not going to just stand there. So what are the scenarios? I talk a bit in the book, but there's a sort of risk of catastrophic failure the more you perennial cities behind sea walls and the seas are rising around the outside all the time, that you get a New Orleans type failure of the levees, then you get a very rapid flooding of large areas, and that absolutely can kill people. But these things actually are quite predictable, and even the most extreme scenarios for sea level rise wouldn't give you more than 2.5 meters by 2100. So yes, that's tolerable for most of the world's coastlines, probably with a substantial amount of money spent on coastal engineering or moving people away. I mean, in the UK, we'll just need to abandon large coastal areas, let them return to the sea or return to coastal salt marshes and things like that, which would be good for wildlife anyway. So we can't, and we shouldn't aim to protect every single part of the land from the rising seas. You also get a problem with saline intrusion into aquifers, and so salt water will find its way into the land, even underground, if you like, which you can't obviously protect with seals either. So there's a different dimensions to this issue too. And so you often hear about the Greenland ice sheet will collapse. I actually think the Greenland ice sheet will collapse already, even at the level of warming we've got now. And I don't think it can be sustained. You've already got melting right to the summit of Greenland. So you're now removing ice across the entire Greenland ice sheet essentially every summer, and it won't be long before that happens all the time, as opposed to it being a fairly rare event now. But when you've got an ice sheet which is 3.5 kilometers thick, how long does it take to actually melt it? I mean, it takes centuries. You can't make it happen in the timescale of years or decades, just because of the physics of that. And Antarctica as well. You can speed things up a bit if you collapse marine terminating glaciers, like in Antarctica you've got the Thwaites and the Pine Island Glacier, less so on Greenland. But the major sort of ice sheet collapse scenarios take a very long time to play out, and so sea level rise as a result is also very slow in a human timescale. It's very rapid in a geological timescale, but it's not going to. I think that's something we absolutely should be able to adapt to, even if we have to move cities inland. Then that's okay. I mean, look at the difference between, say, Hong Kong in 1950, it was basically a fishing village, or Shanghai even more so, and where they are today. So huge amounts of infrastructure. Entire cities get built in the space of a few decades. Building new cities further inland is certainly imaginable.
Okay, so I guess to wrap up this section, it sounds like we agree that the most likely way for climate change to cause civilizational collapse is perhaps if it's quite rapid, or you get like some really rapid increase in the climate effects so that we don't really have time to adapt to it. Probably going through food shortages is most likely, maybe water shortages second most likely. And then it probably also requires that we react pretty stupidly, or we react in a kind of competitive zero-sum way and start fighting one another and just trying to grab the resources rather than try to, instead put our mind towards technology that can solve the problem. And if you kind of get those three things, then things start looking hairy, and we're not quite sure whether humanity is going to make it out in a decent state. Does that sound right?
That's a good summary, particularly if you've got a kind of positive feedbacks which are happening at the same time, so that we're all aware of it. The sunsets are particularly lurid because you've got much of the Amazon is now in smoke circulating in the lower stratosphere, and you've got very large scale melt in the Arctic permafrost, and methane concentrations of the atmosphere are shooting up, and there's a sense really that the whole issue is beginning to slip beyond humanity's control. And I think that would have a huge psychological and political impact in terms of our, it would affect how we respond to it. It's our understanding of how far the situation is now going beyond, essentially going beyond that. You get less techno-optimist if you think, shit, we've pushed the lever so far that we're now tumbling over the cliff.
Nice. Okay. Yeah. Well, I hope maybe we can do a full episode just on maybe with a social scientist or someone who's thought about societal collapse and when do things break down and when do people react constructively in the future. It seems like we could spend hours on all the different sub questions here.
I think people don't tend to have rational conversations about this. You get so in fact you get the collapsitarians and the doomsters who think that societal extinction is, well, not just inevitable, but near-term inevitable and in a little way desirable. You often get that sense from this kind of post-Christian millenarianism, where the environmental challenges are the new kind of hand of God sort of thing.
I see. It's our punishment.
Yeah, exactly. It's a punishment for our decadent, overconsumed ways. There's so much of that in the kind of discourse that you get amongst the more climate alarm alarmed or alarmist sections. So I don't think that's based on that's always based on cherry picking the science, but it's that got through with a kind of psychological angst. And then on the other side, you get the kind of techno-optimists who believe that we can solve our way out of any problem by inventing new things, and it'll all solve itself in some kind of giant Kuznets curve. So I feel like I'm in quite a minority in trying to engage with both sides of that debate and try and have I wouldn't say rational because that's sort of blowing one's own trumpet, but to try and have a sort of numerate approach to how you'd actually discuss these issues.
Aiming toward a rational discussion.
Well, we all can.
I do find it really baffling that there isn't more proper, thorough analysis of this, like academic analysis. I remember years ago, I realized that I just heard so many times this idea that climate change would cause serious conflict, and I was like, I don't really see the story here that's super compelling to me. And then I started looking around. What's the best analysis written on this question, where they break down all the different potential paths to conflict and then think about how likely they are? There's nothing. It's not. People just say this, and then it's just kind of left, and no one really thinks that it's their responsibility to figure out whether it's actually really true. So, I mean, I think there's a lot of potential, listeners, if you'd like to go away and analyze this question, I think there's surprisingly fertile ground here to say something new.
To be fair, there's been some research on climate and conflict in very small scale conflict. And so there isn't nothing, but it's true that it's very underdeveloped.
Yeah, I completely agree. And I guess a lot of the time it's one thing to try and model the response of the Earth system to increase greenhouse gas concentrations, but I don't know how you'd ever predictably model the response of human societies to. I think it's just obviously all of these systems are dynamic and non-linear, but we don't need, like I said earlier, we don't even understand how the economy works. We can't take a rational approach to even to economics, much as many economists claim to try. So how that would then feed through into political responses and cultural responses, it does become almost impossible to say anything with any kind of predictive value, perhaps.
Well, one other thing I might just say to wrap up is, even though I think I feel a bit more optimistic maybe than you do, or I would place lower probabilities on civilizational collapse than you do, maybe because I think, well, if we responded rationally, things would be able to go fine. I think...
Well, not fine, of course.
Right, yeah, exactly. Not extinction level. I think we can see from history that people don't always respond rationally, and that things can be interconnected and very chaotic and really spin out of control when it doesn't really seem like they had to spin out of control, but they did, and there was kind of an escalation of how bad things were. And so I'm more optimistic than you, but I'm definitely not that chill about it. I really worry, and I would really prefer that we didn't have to find out whether we were resilient to these stresses.
Yeah, absolutely.
Okay, let's push on towards talking about specific ways of addressing climate change. And first up, let's cover one of your preferred solutions to climate change, which, as you've mentioned, is nuclear power. So in 2014, you published Nuclear 2.0, Why a Green Future Needs Nuclear Power, which makes the case for a big scale-up of nuclear power, more than doubling the number of plants over 15 years. And I really enjoyed this book because it covers kind of all of the key issues that you wanted to raise very clearly and very quickly. You could finish the book in one session, which is something which was the case of more books. And you also just throw in a lot of numbers to really explain why you hold the views that you do. So yeah, in brief for the audience, can you explain what makes you so enthusiastic about nuclear energy?
It comes down to physics, actually. So you'll like that. It's really to do with the energy density of nuclear as a fuel. And that's the key issue if you're concerned about scalability. You've got to find an energy source which provides carbon-free power to a 10 billion strong population at the same time as people have probably doubled their energy demand or tripled or even more, given that most of the world still underconsumes in relation to us and richer countries. So how you do that without destroying the rest of the world's ecology, right? And there's not really any other way of doing it than nuclear. So fossil fuels are already very energy dense, particularly given that they come from underground. Hydrocarbons are an incredibly adaptable and versatile way of powering long-distance transport, for example. Coal is a brilliant way to run industry and to generate power, apart from a few million dead every year from particulate pollution and small things like that. But, uranium is, something like 1 million times more energy dense than hydrocarbons. And so you can power whole countries with a few tons of the stuff, really. And the materials flows and the waste flows are simply trivial in comparison and raise no significant environmental challenges or indeed engineering challenges. It's just doable. And it isn't doable with any other approach that you can imagine. So renewables are not energy dense. So you have to cover immense areas of land to capture enough solar power through photovoltaic technology to even go a small distance towards addressing our current energy consumption with solar. And wind likewise. These are just, so the power density per unit of land area is very low for renewables and very high for nuclear. And the difference is orders of magnitude.
So that's the case for nuclear, or for scaling up nuclear. What do you think is the best argument against scaling up nuclear power? What's the sort of most likely way you could be wrong about this?
The only argument against is a political one, that people won't accept it or people won't want it. So nothing to do with I don't think there are any engineering or physics challenges that can't be fairly easily addressed. And that includes the cost. I mean, yeah, nuclear is very expensive at the moment, but that's because it's trying to satisfy safety concerns, which are taken vastly more seriously than any other type of infrastructure project, and therefore require multiple redundant safety approaches, which cost a huge amount. I mean, you've got to build, I think, for the UPR reactor at Hinkley, they talk about it's like building a cathedral inside a cathedral. That's the kind of engineering which we're left with to try to reassure the public that this isn't an existential threat. And so, what's that? That's not an engineering challenge, that's a psychological challenge, it's a political challenge. So the only way that I think it's strong is if people won't accept it and we waste time trying to do it, instead of simply paving over whole countries with solar panels, if that's the only way that's politically acceptable.
Just to clarify quickly on the costs point, are you saying you think we should have less sort of safety redundancy in nuclear power, or like more in the others or something, when you talk about, this cost being inflated for nuclear and that being artificial?
Well, I mean, it is one of the major cost drivers. And you need to ask, I mean, no one in the nuclear industry would ever say, let's save costs by reducing our safety components. But those of us who are not in the industry can say, well, look, why is it that nuclear has to fulfill this safety concern vastly more than anything else? I mean, cars aren't that safe. Nothing's that safe.
Coal power is not that safe at all. It's the reverse.
Well, no, not only coal, but even wind and solar aren't that safe in terms of numbers of fatality per gigawatt hour, or however you want to quantify it. People fall off roofs putting solar panels on, and wind turbines fall apart, and whatever. So nothing's completely safe. And even the worst case scenario nuclear accidents, at least with the kind of technologies we're using, I wouldn't use Chernobyl because that's not the kind of reactor that we've got built anywhere else. But say Fukushima in Japan, which was about the worst, that's like a triple meltdown in the context of a much wider natural disaster. So that's about as bad as it can get. How many people die from radiation? Well, 0. So why doesn't that's not even on the same scale as Piper Alpha, where, the oil rig blew up and killed 150 people, or any mid-range industrial accident. So why is it the nuclear has to shoulder these immense costs because of this perception that it's somehow an existential risk? And you see this all the time. People say, well, imagine if, a lot of Greens say this, imagine if one nuclear power plant somehow contaminated another one, and you get this cascading fail, and they actually imagine this is a pathway to human extinction. I've never heard anything so stupid. So people's psychology is so mixed up on this that it's very difficult to kind of draw a line between what's psychology and what's engineering in terms of how you deal with the safety issue. But just to kind of finish up, yes, let's not have to have a compromise between safety and cost. Let's move to different designs of reactors which are passively safe, where you can walk away from them and they will shut themselves down and there won't be any release of radioactivity in almost any imaginable scenario. Those designs exist, and they should be scalable and cheaper than even what we're using at the moment, fortunately.
So in 2014, your main concern was also cost, but there was a bunch of other things you'd like to see improved about nuclear power, like these kind of modular designs and using different fuels. How has the technology come along in the last 6 years in terms of cost and safety and, I guess, practicality?
Well, if you're looking at light water reactors, I mean, Hinkley C is at least being built on schedule at the moment. It looks very expensive because it's a huge capital cost over a long build, so you don't start getting payback for quite a long time. And so it's the cost of capital is really the main issue with infrastructure projects of that nature. But it's the same for building a bridge or the Scottish Parliament or pretty much anything, actually. We're not good at doing that in Western countries anymore, and it always looks eye-watering and expensive to do something big. I mean, look at HS2, the high-speed rail. It's in the hundreds of billions, I think, now in terms of what the projected cost of that is. The Victorians just went ahead and built these things for a fraction. So cost is a moving target anyway. But so yeah, some of the small modular reactors and the more advanced designs have come on a long way. Thorcon, for example, which is one of the molten salt thorium designs, it's got most of the way towards working with the Indonesian government on a prototype and potential build out there. which I think is really interesting. And their design is completely passively safe. And they're looking at a cost, which I think is about $1,500 per kilowatt in terms of the capex. So it's about a fifth of the cost of an EPR. So that's what, I mean, obviously these are quoted prices and you don't know until you actually do the thing. And even then, the prototypes for the first of a kind cost is obviously a lot higher than the nth of a kind cost when you're doing lots and lots of these things. So, if our only, roadblock that's in the way of stopping climate change is making nuclear cheaper, I'm sure we can do it. Just as happened with solar. I mean, solar is now way cheaper than it was. Again, orders of magnitude, than it was a couple of decades ago, and nuclear can do the same.
Yeah, so speaking of which, kind of costs for solar and batteries have just come down a lot since even 2014 when you wrote that book, and maybe they've even been coming down faster than people predicted then. Has that made you reconsider at all whether nuclear is really necessary and whether we might be able to do it just with renewables if we had to?
No, because the power density of renewables doesn't change. That's a physical reality, which is related to the amount of sunshine or kinetic energy that you can harvest from a particular unit of land area. I mean, you can get slightly more efficient solar panels, but it's a few percentage points at most. So you're never going to be able to get away from the fundamental issue of needing to pave over country-sized areas of land to generate enough renewable power to fuel modern industrial civilizations. That's a fundamental physical reality which is never going to change. And it might be slightly cheaper to do that because solar panels have come down in cost, but it doesn't change the fundamentals. So no, I'm not really in a different place from where I was in when I wrote Nuclear 2.0.
Couldn't we just stick all the solar panels in a desert somewhere where practically no one lives, and then put up high voltage lines to transmit them to cities? Can we get much mileage from that?
Yeah, but there aren't. Yeah, but even deserts are ecosystems, and they're wild areas. When I think it's Ivanpah, the big solar plant in California, Mojave Desert, was being built. They were bulldozing cacti. They were pulling desert tortoises out of their burrows and sticking in the back of pickups to be translocated elsewhere where they all died. There's no such thing as an ecological free lunch, particularly when you're talking about harvesting power over vast areas of the planet's surface, which are currently still wild. That's the opposite of, a rewilding agenda, which is what I'm most enthusiastic about, where we need to let go of human impact over as much of the world's land as we can do while still producing food. Why you'd want to bring energy into a land use conflict when we've already got food in a land use conflict, I can't imagine.
So, guys, my overall view is that I'm super sympathetic to nuclear power and what you're saying, and I'd be really happy to see more plants getting built. And it's crazy to see plants getting shut down early and then replaced with coal power in some places. And I guess a lot of the common objections that people have around safety and other things are pretty weak. But all that said, I'm not sure whether promoting nuclear power is kind of a top low hanging fruit way to reduce climate change. I guess for three reasons. So yeah, firstly, there's this thing that solar is decreasing so much, and maybe I'm more optimistic than you that we can find some way to stick the solar panels in some place that people will accept. At least maybe that's easier than getting a nuclear built. And I guess if solar cost decreases continue, then maybe it will just end up being cheaper as well. Then there's also, I guess, as you say, Europe and the US just seem to have forgotten how to build things now. And it's hard to get a bridge built, let alone a nuclear power plant. And I'd love that to change, but I guess I'm not holding my breath. So maybe nuclear power has more of a future in Asia or something rather than Europe or the United States. And I guess also, like you said, people just hate nuclear energy so much to such a irrational degree that the NIMBY problems just seem really severe. And while I'd love that to change, I guess I'm not sure whether making all of these sensible arguments about why it's actually a good option is going to be enough to get rid of people's instinctive fear. Did you have any take on that?
There's a lot there. But
yeah, sorry.
it comes down to are you serious about having a plan to tackle climate change which actually adds up in this physical principle? And I'm putting that question to Greenpeace, to Extinction Rebellion, to you, to the Conservative Party, whatever. If it's a renewables only approach, then you're not serious. I mean, it just isn't conceivable to imagine the kind of materials flows. And if you put all of the solar in hot deserts, but the transmission lines, you've got a transmission line, let's say, between Algeria and Libya. Oh, Libya's just gone. Whoops. There's energy security issues for that, just as there are with the modern day oil industry, where we've got geopolitical, obviously, conflicts resulting from our dependence on Middle Eastern oil. So yes, you could probably design an outcome where you've got most of the Arabian Peninsula covered in solar panels. Electricity to the high consuming markets is very difficult, even with high voltage DC cables, not to mention the security risks of that. But perhaps a better option is for hydrogen production, so to produce synthetic liquid fuels using the sort of stranded asset of hot deserts. And I know people who are working on that, and I think it's certainly conceivable that could be a significant part of the approach. So I'm not so when I try and be kind of physically realistic about the renewables issue, it's not to say we shouldn't do renewables. I'm currently involved in launching a campaign called Nuclear for Net Zero. I don't know whether it's going to happen or not, but we're just kind of conceiving of it at the moment. And I'm quite happy to say, okay, let's have in the UK solar PV equivalent to 10 times Hinkley's D. So let's build your 1.5 Waleses of solar. I don't know quite where you're going to put it. Actually, it's not that much. It's only about two Surreys, actually. So let's just sacrifice a couple of home counties to solar by all means. But we'll still need, even a few, well, probably 40 or 50 gigawatts of nuclear as well. And if you've got offshore wind, and if you're going to produce significant amounts of hydrogen in the UK too. So the only way you can get around that is to say, no, of course we don't want any solar in Surrey. We're going to have to put it all in Algeria, in which case you've somehow got to either move the electricity, or I'm not quite sure how else you're proposing to do it. So is that more believable than a future where you basically just persuade people to be a little bit less hysterical about nuclear and to get that back into the mix as a much more scalable and hopefully more cost-effective approach? Because, by the way, even with the reduction in solar costs, it's much more expensive to do it just with solar and wind because of the materials you need. Imagine imagine all the steel and silicon and all the rare earths and everything, all the different metals that you need to cover over the Arabian Peninsula with solar panels. I mean, it's immense. It's probably many times the scale at which these material flows currently exist for all of the world's industry.
All right, let's move on from nuclear power to discuss other promising ways people can help to reduce climate change. So what are a few other policy or technology options that you think have the greatest potential to avoid a climate disaster?
There aren't any.
So it's just nuclear?
Yeah.
Okay.
That's why I can. I don't have a particular, some kind of strange fetish for reactors.
Well, I guess people talk about a carbon tax or these kinds of things. Do you think any of those are especially promising?
Those are policy levers which have to drive a technological change. What's the technology? So ultimately you come back to the same question.
Okay.
You don't think it would be, well, I suppose I would think of solar R&D, even if you think it can't go all the way, is helpful as well. And then there's maybe battery technology could help. It just lowers the overall cost of having stable electricity from renewables. Is there kind of anything else on the energy side that excites you?
Well, when I said we could pave over the whole of Surrey with solar, that's assuming that you've dealt with intermittency. So that's just looking at your watt hours per year. I'm not talking how you keep the lights on at night. So batteries, no, that's not an issue at all. There's nothing else. I mean, fusion, good luck with that. Biofuels, no, that destroys more of the planetary ecosystem.
So I guess another type of intervention would be negative emissions technologies. So carbon capture and storage, for instance. How optimistic are you about that for making a big difference?
You mean carbon capture and storage from burning fossil fuels? What carbon are you capturing and storing here?
I'm imagining the atmosphere, but would be curious about the others too.
Well, so an air capture, your thermodynamic challenges for that are you have to put a huge amount of energy into that process. You've got to somehow chemically strip CO2 out of the atmosphere where its current concentration is 400 parts per million. So that's 0.04%, 0.004%. I can never get the orders of magnitude right, but very diffuse. Then you've got to concentrate it, liquefy it, and pump it underground in big pipes in appropriate places. So the scale of that challenge, if you think about it conceptually, is like doing the opposite to what the oil and gas industry has done, times 2, because it's coal as well, for decades. And you think about the size of all of those pipes and all of those drilling rigs and all of the rest of it. Is that going to happen? And you'd have to put into that much more energy than was liberated in the process of drilling and burning that oil and gas to start with, obviously, because of thermodynamics. You've got to, it's like trying to make a wood fire out of ash, right? You're the lower state of energy, of entropy. So no, it's not going to happen. No, it's not scalable. And no, it shouldn't be a major part of our conversation.
Yeah, I'm with you on that. I guess also in the meantime, you've been burning coal and messing things up and producing all the air pollution, all the other downsides of coal. It just seems terrible on multiple different grounds.
And why would you do it when you've still got point sources of emissions, which are releasing concentrated CO2 by the millions of tons from single chimneys? In what way does it ever make sense to try and then capture it from the air at 400 parts per million concentrations? So you've got this strange parallel conversations going on. It's almost like, for me, it's a kind of psychological denialism, and imagining that some kind of future yet to be invented magic can reverse the damage that we're currently doing every single day.
Yeah, even magic can't change the laws of thermodynamics. Well, what about grabbing it from the chimneys of the coal plants? Is there anything to be done there?
Well, that's the methadone option to your heroin addiction.
Sounds like an improvement.
Maybe. You're still an addict and you still flop around looking grey. So obviously you can carry on burning coal and you can put the already concentrated CO2 underground. And that's being done in a small scale in some places. So technically that's manageable. You get a significant energy penalty in doing it. And to be honest, the best way to keep carbon in the ground is to leave the carbon where it currently is in geological reservoirs of coal, oil and gas. So it doesn't make any sense to do that, in my view, as a sort of large-scale approach. We just don't need to. We've got alternatives. We don't need to burn that coal to start with. And it's better off being solid, black, and a few hundred meters down.
Okay, given that, maybe we should talk more about nuclear.
Yeah, I've told you. You end up with nothing else, nowhere else to go, which is the process I went through in about 2005.
Yeah, that's interesting. So tell us a little bit about your evolution from being anti-nuclear to pro-nuclear. How did that happen, and how difficult was it psychologically?
Well, I was never anti-nuclear in a mobilized sense, in the way that I was anti-GMO, where I was doing actions and destroying crops and things like that. So I was never an anti-nuclear activist in the sense, anything more than the fact I felt myself to be an environmentalist, and therefore I thought nuclear power was bad, because all environmentalists do. But so that was really the extent to which I thought about it. It's a generation before me. I mean, the kind of high watermark of the anti-nuclear movement was in the 1970s, China syndrome type era, Jane Fonda, that kind of stuff. So I came of age really as an environmentalist in the the early 90s really. So that had happened, but it had become, for want of a better way of putting it, part of the DNA of environmentalism was the anti-nuclear belief. So I just grew up with it and never thought to question it.
Until you did, though, I suppose. Right? So yeah, what was that transition like?
It was very difficult. Yeah, I mean, I was at a energy conference, I think, where someone from the nuclear industry just said about, I think it was 15% of the UK's power at that point, and I didn't even know. Actually, it hadn't really occurred to me the extent to which we're already dependent on nuclear for, well, at that point, the majority of our carbon-free power. And so at the first stage, I was like, okay, why would you don't want to switch it off like they're doing in Germany. If you switch off the nuclear, then you go the opposite direction from where you need to be to reduce emissions. So once you believe in the climate emergency, you just have to rethink an opposition to nuclear. Not doing so is, well, completely irrational.
Have you had much success persuading people? Are there any kind of green shoots of people reassessing this?
You would be surprised of how many people deep down
think it's fine.
Yeah, actually understand. But it's a bit like most people are still in the closet. But we need to. So this is why I'm focused now on helping build a movement, because we need to be out and proud. We need to say, this is what we think. This is the reasons why we think it. And please join us. Rather than, I know people in Greenpeace, Friends of the Earth, and all of these mainstream groups who know perfectly well that you've got to have nuclear as a major part of the mix to solve climate change. But they would be sacked if they said so. So they just keep the lid on it. And I don't think having to deny evidence is the right place for environmentalism to be. So that irritates me, as well as it being in the way of solving climate change, which is the main point of this whole exercise.
Are there any recent innovations in nuclear energy, or improvements on light water reactors of the past, or forthcoming potential innovations that you could talk about that might get people more excited about it?
Yeah, I really like some of the molten salt reactor designs. It just makes more sense to have your fuel liquid rather than having your fuel solid and trying to stop it turning to liquid, which happens in the conventional light water reactor, where you get the meltdown is the most fearful thing. If your fuel's already liquid and it's mixed with salts, then that's where the fission is taking place. That just makes a lot more sense. It also makes more sense not to use water as your coolant, because then you've got to have a pressurized environment. If you're going to have water at 300 degrees C, it's got to be under huge. So then the whole system has to be at a very high pressure. And then if anything goes wrong, it's very difficult to get in there and do anything, because whatever's inside is trying to get out the whole time. And so you've then got, just by the design of the thing, you've got a more difficult safety environment. If you've got pressurized water at 300 degrees and, you have a loss of pressure or loss of power or anything like that. So the light water reactor design, which we were left with in the 40s for submarines pretty much, and then became the sort of standard for commercial, for civil nuclear power, isn't at all the best. If you're going back to first principles, you would not design a nuclear fission reactor that way. And I quite like also the fast breeder aspect of thorium, in that you're breeding more fuel into existence. And by the way, there's enough thorium to run the planet, even at kind of US standards of living, for like 10,000 years. It really is not a limited resource in fuel sense. And the designs have this very clever freeze plug thing where you have to blow, let me get this right, you have to blow very cold helium on it, and that keeps the salts frozen at the bottom. So if for some reason you get a loss of power, that stops happening and it thaws out, and then all of the molten salts, fissioning molten salts, drain into all of these very separated tanks, which are passively cooled, and there's nothing you can do actually to make it blow up, even if you were to try. Whether that would persuade people who are fearful of the whole concept of radioactivity and the atom, I don't know. Possibly not, but I would quite like to have reactors out there which were passively safe. I mean, I think it's just a better prospect.
Yeah, this has really inspired me to go and really investigate these things more properly, because I guess how nuclear power actually works and what the possible advances are has always been a bit of a blur to me. People talk about them, but I don't really have an ontology in my mind of the different choices that we potentially have to make. Are there any sources you can recommend on, if someone really wants to get up to speed on where we are with nuclear energy today, what the problems are and what the possible solutions are, where might they go?
Oh, that's a good question. Well, Thorcon, and so some of these new designed companies actually have good videos and just explain how the whole thing works. But I mean, there is this sort of debate between the light water reactor proponents and the and the sort of advanced design crowd, sort of fast breeder crowd. But I think ultimately we have to go in that direction. There's not that much uranium-235 out there. It makes sense to use this stuff a bit more productively.
Sorry, explain that.
So natural uranium in the ground as an ore, which you obviously, you obviously purify to make into nuclear fuel, is at a natural concentration of the uranium isotope 235 at only about 0.5%. The rest of it's uranium-238. And having those extra neutrons means that uranium-238 isn't fissionable. So only uranium-235. So this is what the Iranians are doing with their centrifuges, is to try and increase the proportion of uranium-235 so that you can get to where you need to be to build a bomb, where you need over 80% uranium-235. So you're going to get it from 0.5% to 80%. You do that through centrifuges which are spinning gas containing uranium. So the heavier stuff goes to the outside and the lighter stuff goes to the inside. And you do that through several thousand centrifuges. You can gradually increase the proportion. But so uranium-235 is the fissionable isotope. Uranium-238 is non-fissionable, but comprises 99.5% of what's out there. You have to enrich uranium, which is doable, but then you've obviously got the issues with controlling proliferation risk and stuff like that, because it's the same stuff. But you only need it to be like 2% enriched to make nuclear fuel, whereas you need 80% enriched to make nuclear bombs. So there's enough difference between them that it's very easy actually to figure out when a country, some rogue state, is trying to do that. The only complication is plutonium here. So in a reactor, uranium-238 will capture a neutron and transmute to plutonium-239, which is also fissionable and which was also a component for nuclear weapons. So I think the Trinity bomb or the Hiroshima bomb in 1945, one of those was plutonium, one of those was a uranium weapon. So actually a lot of the fission that goes on within any nuclear reactor is uranium-238, which is turned to plutonium-239. Potentially, if you get that out and find a way to purify it and concentrate it, you could then have a proliferation risk that weapon could be created. So this is one of the objections that people sometimes raise. But actually, if you can turn uranium-238 into plutonium, then again, you've got pretty much inexhaustible fuel supplies. So in many ways, to my mind, that's a reason to be more enthusiastic about nuclear than less, because you can run a highly energy consumptive developed civilization for centuries, millennia, using this source of fuel without destroying the climate.
Why are you less worried than some other people about the proliferation concerns?
You just have to keep control of the fuel cycle. I mean, this is what pretty much already happens. I mean, every country doesn't make its own nuclear fuel. It's a traded stuff because it's quite specialist and requires a lot of difficult, complex equipment to make. So you have a few places which make it, and then they take back oftentimes they take back the waste and they reprocess it or whatever. But either way, the whole fuel cycle is safeguarded within internationally regulated scenario. That's what part of what the IAEA exists to do.
If there's listeners out there who are, listen to this and they read your book and they're like, yeah, nuclear is the way to go. What opportunities are there for them to make a difference? Do we need kind of advocates or, people to go into engineering or business? Yeah, what can we push on here?
We need all of those. We need enthusiasts, we need engineers, we need innovators, we need activists, we need everybody who's interested in this issue to be out there and talk to their friends about it. You remember, this is a cultural awareness shift that we need more than anything. It's, yes, the engineering challenges need to be addressed too, but imagine if there was like 80% of people were enthusiastic about nuclear, and there was, we were putting a few billions into research, and everyone was supportive. It's a bit like making a COVID vaccine. It would be this like big project that everyone would be excited to be involved in. Imagine how different that is from the current situation where it's this kind of hideous,
almost
thing.
Taboo.
Yeah, it's really expensive, but we've got to do it because we sort of, whatever.
So does that mean that we maybe especially need people doing advocacy? And if so, are there particular types of advocacy you would guess are especially effective for persuading the people who need to be persuaded?
Yeah, we needed a pro-nuclear Extinction Rebellion. I mean, if Extinction Rebellion was to carry through its mandate properly, it would be pro-nuclear. I mean, it's one thing to put pink boats into the centre of London and say we're in a climate emergency, but then people say to you, well, all right, what do we do about it? They say, well, we don't do solutions.
Are there any companies or organizations or maybe university research projects that you'd be really excited for people to go and join?
Well, we're currently, I think actually it's more of a philosophy. So I would sort of hesitantly call myself an eco-modernist, which is this whole we wrote a manifesto a few years ago to try and codify this as a sort of evidence-based environmental movement, right? So to try and bring sort of scientific rationalism into the green scene, and to be progressive, because a lot of environmentalism actually isn't progressive. It's very conservative, even reactionary. It's about going backwards and keeping people poor. They don't say it in those sense, but pretty much it is. Or
they don't care enough about those side effects.
Well, I think actually, I think it's a defined.
Really?
Yeah, I mean, if you look at the GMO stuff, they don't want farmers in Africa to drive tractors and use fertilizer. They want them to remain in subsistence, cultivating crops by hand, because they consider that's morally desirable. That's the whole idea behind the organic movement, really, is to try and reduce the amount of technology that's used in agriculture. Why you do that in a very low-tech subsistence, then with very low productivity and, the constant risk of food insecurity, it isn't really fair if you're a well-off, rich, well-fed person. Then try and externalize that into Africa, but that's pretty much where all of the NGOs and the entire aid budgets have gone.
Yeah, I guess. Go on.
Aaron always wants to be really charitable. Maybe we can just say there's some people who feel this way and there's some people who don't. There's a range of views. Given what an uphill battle nuclear has in kind of Europe and the US, are there other countries where maybe advocacy would be even more useful? Maybe in China, it's people are already more positive about it, or maybe there's developing countries that need more energy where people are more open to the idea of building nuclear power plants, and that's where we could really see a renaissance take off?
Yeah, that's a great question. I mean, maybe Indonesia, India, countries which are relatively open, but which have a huge need for clean energy. So, yeah, but there isn't a pro-nuclear movement. I mean, there's no pro-nuclear grassroots movement anywhere in the world. There's one or two successes, like in Finland, for example, the eco-modernists there is like literally just half a dozen people to start with, but they've got an MP elected now who's a member of the Green Party, but has an eco-modernist philosophy, and they've got support from all of the different political parties, and Greenpeace has gone quiet on nuclear at least. So you're at the stage now where it's flipped over, and being pro-nuclear is sort of the sensible position to have in Finland. Now let's try and get there in the rest of the world.
Yeah. One thing you talk about in the book is kind of modular designs, which might allow us to, build plants more quickly, on time, and at lower cost. Do you mind talking about that for a second?
Yeah, no, far away. I mean, it's a bit like how you make ships. And so you could there's some people I've been working with who actually look at other ways to make modular reactors in shipyards, essentially, where you're building very large pieces of incredibly complex engineering and steel, and all put together in the space of a few months. And they roll off a production line, and you've got a very highly skilled workforce with all the sort of modern robotics and everything right there in one place, ready to produce them. Because even if you do it with nuclear, it doesn't make it easy. I mean, the scale is still immense. If you were to replace, again, just to throw a number out there, if you were to replace our current global oil consumption with nuclear generated hydrogen, you'd need the equivalent of the entire nuclear fleet produced every single year, which is like 400 and something gigawatts. So are you really going to design and build 400 light water reactors every single year? I don't think so. You're going to have a completely transformed approach to the whole production chain, all of the manufacturing process.
Yeah, what are the challenges there, or do you think it's just something, if we put in the effort, we'll figure out a way of making these smaller reactors in a more systematic way?
Oh, it's already. I mean, it's not only been designs are out there. I mean, it's got much further than that. Where there's Korean shipyards who are already giving quotes to nuclear engineering companies for how much it'll cost to do this. But you need the first ones to be built, obviously, before you can start thinking about the next several hundred.
No, actually, are there any opportunities for donation or investment here? People often ask, what for-profit stuff can I invest in, or what socially responsible investing can I do that would improve the world? And often I don't have a lot to say to them, but maybe this is something I've overlooked.
Yeah, but go and put some money to Thorcon. I think they only need a few $100 million to get the first prototype, which is peanuts, really. And once you've got, and there's a big jump between a paper reactor, as they say, and one which actually is working and has been through all of the tests, been fully licensed and is scalable in that sense. So that's the gulf that needs to be jumped with the advanced designs.
I know you're also an advocate for GMOs and change your mind on that. Do they have any role to play in preventing climate change?
Hugely, in terms of increasing our adaptive capacity. You were talking earlier on about how we can avoid famines, and if you want to be in a situation where food crops can still grow in a hotter, drier environment, you're going to have to change their genetics. How are you going to change their genetics? Well, you'll need to use genetic engineering. This isn't complicated for people to understand, I wouldn't have thought. And so, yes, GMOs maybe could buy us a decade or two in terms of avoiding the supply shortages that might otherwise arise from, low to moderate levels of warming. And also they can make, and are making, agriculture more sustainable. If you've got insect-resistant crops which fend off insect attacks, then you don't need to spray them with insecticides. There are crops which are disease-resistant. So in Uganda, where I was a few years ago, they've got a big problem with bacterial wilt in the staple banana crop. There's GMO varieties of banana already in beyond the lab. I mean, they're already in field trials, which could solve that problem, basically. But because they're GMOs, you've got this huge fear-mongering campaign, which is fully supported by Western aid agencies and NGOs, which has basically blocked up the political process in Uganda so that they probably won't ever be released. Well done, Westerners. You've managed to stop Ugandans having disease-resistant banana. Big round of applause for everyone, I think.
So for GMOs, do you think that the main things that listeners could do if they wanted to contribute to adoption would be advocacy again, or is there something else maybe that people could do if they were passionate about this?
Well, there actually is quite a strong grassroots pro-science, pro-GMO movement in Africa and elsewhere, which I've been involved in helping to kind of coalesce through the Cornell Alliance for Science. So visit Cornell and join and become an advocate as part of that broader network as well. But again, I think so much these days comes down to social media influencing things and just talk to people. I mean, it's not experts who persuade anyone, it's your friends and your relatives. And so just talking to people who trust you about this is an incredibly powerful tool, and is ultimately the thing that will make the difference.
Do you know if there's been any research on kind of what messages are most likely to change people's minds? I guess especially about nuclear energy, but maybe also GMOs. So one thing is, when you talk about this stuff, unfortunately I stopped studying physics in year 10, so I was like 15, and often I feel like my eyes just kind of glaze over when people start talking about the technical details, which makes me feel more sympathetic to people who are just like, I don't bloody know anything about genetic engineering, and so maybe it is dangerous. I can't follow this conversation. It's difficult.
Yeah, it is difficult, but then that's why it ultimately comes down to trust and expertise, because you won't understand molecular biology, and you won't understand nuclear physics, or you won't understand both of them at the same time. Even though people got different groups of experts who do that, and I'm not claiming to be one of them. So my information comes from what's published by experts, and it's the same with climate. You're not going to understand the physics of greenhouse gases either by your own experiments on a Wednesday evening. So it comes down to the kind of compounded knowledge of which has been generated by experts working over, well, not just over years, but over centuries, actually, in terms of where science came from. And so you can't gain an understanding of these things from your own anecdotal personal experience, let's say. That's where belief in magic and superstition come from, is our trying to misallocation of cause and effect, which is a very human thing to do. But if you're to get beyond that and to have a situation where empiricism actually makes a difference, then you have to trust in experts, because you have to trust in the people who come up with the numbers and have explained them. And ultimately, that's the real challenge in any of these areas is trust. And if you believe that climate scientists are lying to you, then you're going to vote for Donald Trump. You're not going to advocate for addressing that problem. If you believe that GMOs are going to poison you, then you're going to stop Africans being able to use them and address their food insecurity challenges. If you believe that nuclear is this sort of magically toxic, awful thing, then you're going to keep campaigning against it and result in more coal emissions. So all of this stuff ultimately comes down to people's willingness to believe in expertise and to have a more empirical, more science-based view of the world.
I know you've got to run, so we should probably wrap up. I think maybe a final question is, you think most people are wrong about nuclear, or they're too worried about nuclear, too worried about GMOs from the safety point of view. What other things are people wrong about? Do you have any other heterodox views?
They shouldn't be heterodox, because that's where the scientific consensus is. So,
completely, yeah.
No, yeah. Well, so I'm not a contrarian in that sense. I'm pro-vaccine.
No.
Look at some of the other areas where, a lot of it comes down to conspiracy theories, really. You have to believe, to be a climate skeptic, you really have to believe that thousands of climate scientists have collaborated in a conspiracy to lie to us for some reason about climate physics. Same goes for vaccines. It comes down to a conspiracy theory about Big Pharma and Bill Gates, and that they're somehow poisoned with toxic mercury or whatever it happens to be. But that still comes back down to the same thing. Why do people not take an evidence-based view? Why do people believe in conspiracy theories? It's because of, it's because they are simple narratives, simple politicized explanations, which, kind of foment a distrust of authority, which, is valid in many contexts, but not when it results in large-scale public behavior, which is, injurious to the commonality, let's say.
I'd be curious if there was another sort of technology or something that you think is really underappreciated.
Yeah, no, maybe it'll be ammonia. Ammonia is interesting stuff.
What do you mean?
Well, the problem with hydrogen in the hydrogen economy is that it's very difficult to move around. You have to cool it to 20 degrees Kelvin, so 20 degrees above absolute zero, to be able to get it liquefied, or obviously under very high pressure. So it's a very energy intensive and difficult thing to do, to move large amounts of liquid hydrogen around. So you need you need something to carry hydrogen in a molecular bond. Ammonia is very good at that. Ammonia is NH3. So you take nitrogen, which is all around us in the atmosphere, combine it with hydrogen, bang, you've got a fuel which is liquid almost at ambient pressure and temperature. It has to be a bit cooler, but very easy to do. And you can more or less burn ammonia in diesel engines or in fuel cells or whatever. So do either of you know about the exciting prospects for ammonia?
I had never heard of it. No.
Never heard of it.
Which is a good sign. Maybe our audience wouldn't have either.
All right. Well, on that positive note, hopefully there's lots of other technologies there that we can find out about that will improve things. And our guest today has been Mark Lynas. Thanks so much for coming on the 80,000 Hours podcast, Mark.
It's been my pleasure. The 3 hours have simply flown by.
Just a reminder that as part of our efforts to improve our climate change content, earlier this year, Arden made a medium-sized update to our problem profile on climate change, adding more discussion of long-range climate forecasts and the most extreme risks. You can find that at 80,000hours.org/problem-profiles/climate-change, or just click the link in the show notes. The 80,000 Hours podcast is produced by Kieran Harris, audio mastering by Ben Cordell. Full transcripts are available on our website and made by Zaki Ulhak. Thanks for joining. Talk to you again soon.